So welcome everyone. A very warm welcome from our side, from Menno and myself. Welcome to Telco Electronics and also to join the first OCP Technology Day here in Netherlands. We have a participant from the country from Western Europe and also from Russia as well. So I think this will be a very interesting discussion for all the applications and some of the ideas in the future. So I would like to go through a few things as ice-breaking to you. Actually, in the field, we talk to a lot of practitioners and all the specialists in the field. A few questions in their mind to adopt the new technology of OCP and BISDN and NFV. So the first idea is that how they accommodate all the facilities in the future. The power architecture, the cooling systems, the AC power, the DC power considerations. So this is actually the first one. The second one is the technology. They don't want to invest in long so this is actually the second concern. The third one is the ROI. Okay, how are we all going to pay back to our investors from all the investment? And then it's the regulatory concerns. So these are the concerns in deploying the new technology, including the OCP idea, the open hardware idea, and the SDN NFV technology in the field. Second thing I want to share with you is that this is the platinum member of the OCP members by March, just 2 months ago. Okay, this is the latest platinum member by May, yesterday. So you can see all the players in the field, they are moving into this direction from the OCP. So we don't need to expect what is the benefit, but they do see some benefits, so they want to go into this area. Not only the vendors, but also the user groups. Okay. And we also have the open networking user group in the US, including all the financial institute in the US. They also want to move into this direction. So these two things shows that we have a question, and we also have an answer to this question. So today I'm not going to give too much information to you, but I will let John to do an opening for us so that you know the OCP initiative and how we are going to implement OCP ideas in the future. So I would like to briefly introduce the agenda today. So the first topic is Open Compute Project Initiative and Implementation. We have John from OCP Foundation. He will give us an overview and how you implement the technologies and the hardware, software in the field. And Menno from Telco, he will give us an example how you do the implementation, how you do the planning, how you do the real setup of all the systems. And then the second topic is on the server and power. You know that server actually consumes the 80% or 90% of the rack, the power supplied to one single rack. So we are going to have Dhiman from Wiwwyn to introduce to you the latest development of OCP servers and the power considerations of OCP servers. Also, we have Dr. Wallmeier from Telco Electronics. We will introduce you how to select from 12 volt or 48 volt. What are the considerations behind? What are the factors will impact to your future implementation? Even for telcos, even for data center, for other ISPs. The last topic will be networking on SDN, NFV, software, and hardware. We will have Dr. Woesner from BISDN. He will introduce to you the most important ideas regarding the southbound traffic flow control regarding the open flow protocol. And then we also have Dimitris introducing the entire software architecture for the southbound connection. And we will have Dhiman here to introduce you the open networking ecosystem as well as the implementation in some of the telcos. So these are the topics for today. Just to give you a few information, today we are going to live streaming this session to the YouTube channel. So please, if you have any phone calls, you can step outside to talk. Keep quiet in the meeting room. And then from every presentation, we have 15 to 20 minutes of open discussion. So the presentation will not be long, only for 25 minutes to 30 minutes. After the presentation, we will invite all of you to join all the discussion and questions with the speakers. So this is the setup for today. Is it okay for everyone? Okay. And then next I would like to welcome Jackie to give a warm welcome to all of you. Jackie is actually the president and the general manager of Delta EMEA, and we are happy that we have this facility to conduct this session today.
Good morning, everybody, and welcome to Delta Buildings. My name is Jackie Chang, and not the movie star, but quite close to that. And I hope you will enjoy the whole day today, and I think it's Milo and John, the OCP, and all the participants to come and join this event, and they did spend quite some time. And we want to make sure you feel comfortable about this summit, and make sure you get all the best knowledge and the communication happen in this event as well. And most importantly, you are also welcome to look around our buildings to see whatever things you might be interested about, which is we might could have any further collaboration in the future. Thank you and enjoy your day.
Next, I will hand over the stage to John, and we will start today's topic for OCP Overview. So, John?
Cheers. Right. Need to go right back to the beginning. That's the last slide. I think that's the last slide. Can you take it right back? So while I'm here, I'm going to get you all talking to each other. Nice to see you here. I know it's amazing how many people I know in this room. Amazing. I'm John Laban. I'm the representative for OCP Europe. It's only a part-time job. But what I want you to all do is to all mix and learn from each other, because you have to look at OCP as a complete ecosystem. We had a very interesting discussion earlier, talking about the impact on the mechanicals from the software on the servers. So you really need to kind of understand all of the subsystems in the data center to understand how it's going to impact the data centers, and it's quite profound. Right, so this is me. Is that streaming?
Yep.
Hello. So we're at slide 1. Now, I got involved with this a few years ago. I did some consultancy work for Facebook in Sweden at their big data center. They've got a big OCP data center there. And I was just staggered about what they were doing. I couldn't believe how clever it all was. Just the energy efficiency, the way the software is used to eat hardware. And I thought, this is the future. So I came back and I sold my installation business. I used to have a company that designed and built data centers. I just felt that there was no future in enterprise data centers. And I'm on track. I'm on track. I think the future is going towards these larger data centers, and the future is really changing. And what I'm going to be giving you here in a way is a little bit of careers advice, to revisit where you are now and adapt for what's coming next. And it's coming very, very quickly. It's coming much quicker than you think. Okay? So I just do 1 or 2 days a week part-time for OCP, and I spend a lot of time with Menno, who probably knows more about OCP on the technical level than anyone I've met. So if you want to know anything technical, this guy here is really good. Now what I want you to do, I would like you to kind of talk to the person next door and introduce yourselves. And then what I would like is that you ask them 3 questions that they'd like answered today. Okay? And then I would like you to email them to me, one of those questions. So you're going to speak to him. You're going to get to know him. Yeah? And then 3 questions. Share your business cards, because the success of this is going to be the networking that's going to occur from this event. okay? Bringing together partnerships. Because what I need from you, I need to know what it is you want answered. Why are you here today? So if you could do that, please, just speak to the person next to you. 3 things. Crack on, I'll just wait. Go on. Come down here. Come and sit here. Don't worry. This is important. Introduce yourself to him and these guys. Mark's working on a project very specific to your colos.
Okay.
So you must get to know him, okay? Yeah.
Your microphone is touching your...
Bring it down and ping it, put it here then if it's touching my neck. Could you get us a bottle of water or some water? He's repositioned it. The microphone.
Yes, but there's the microphone for the streaming. This is for the audience here. Maybe will be.
I'll ask them.
Okay, so I'm.
Yeah, I'll ask them.
Okay, John.
Thank you very much. Right, you all got to know each other a little bit? Yeah? Hello, 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 hello. Don't worry. Right. That's your 5 minutes. That's your 5 minutes. That's your 5 minutes. Quieten down a bit. Quieten down. Quieten down. Quieten down. I've created anarchy. Now, just... What I forgot is that there's too many Dutchmen in the room and they don't stop talking. But no, it's great. Now, what it is, it's important that you do get to know each other. And that email address, if you can, please email me some questions. What it is that's something that you want to know and want to be answered today. Okay? It's important. If we don't know what it is that you want to know, we can't give you those answers. Okay? So let's get back into the presentation. Okay? Okay? Now, I discovered this and I needed to tell somebody about this new technology. So that's what I'm here to do. I'm just telling you about this technology. Now, it's really important because you won't adopt this technology unless you change. It's really radical. is very radical disruptive technology. Very radical. Now, I'll show you this video if I can, and hopefully it will come up. Have you got Wi-Fi on there?
Yeah.
That should come up as a YouTube video. And what this here is a video that's just been produced by Nokia. Can you try and play it? Can you try and stream it? If it don't come up, don't worry, you're going to get all these slides afterwards. I know, you have to go back. What it is, it describes what's happening in the telco market. Okay? OCP has now been adopted by the telco players. The telco players are going to be implementing OCP at scale, and most of them will be finished by the end of this decade. And the reason they're doing it is because the over-the-top hyperscalers, the likes of Google, the likes of Facebook, are totally destroying their revenue streams for the telcos. So the way the telcos are addressing this, they're going in, they're copying the technology that hyperscalers use. And that's the only way they can compete with them. Now, this is a huge area of opportunity, picking up this telco business. And it's going really fast. You're only looking about 3 years, 4 years. And sitting in this room, we've got some people from France who have got some really kind of good ideas on how you can address this market. So it's a huge opportunity. Okay? Now don't worry if it doesn't stream. Click to the next slide. But it's really important that you don't miss this opportunity. It's a huge opportunity. And it's moving very, very, very fast. And it's not just the fixed landline telcos, it's all the mobile telcos as well. And it's happening extremely quickly. If I look at the amount of telephone exchanges that are currently being converted in America by AT&T into OCP data centers, it's about 4,700. There's companies that you've never heard of that are involved on these projects who are now moving into Europe, and they need help. They need help because the telcos are pushing everybody in order to survive by the end of the decade. Okay? It's a huge opportunity. This is what OCP is. It basically was started in 2011. And it was started as a result, Facebook designed their own infrastructure in the end. And then they open sourced it. They open sourced it with Intel, they open sourced it with Rackspace. And what I mean by open source, they took away the patents so anybody can make it. And what OCP is, it's an open source hardware community similar to the Linux community. And there's something, you can't argue against this. In open source communities, products are better and they're developed much, much faster. And this is why what's happening now in the hardware space is happening so fast. Really, really quick. If I asked what is the penetration of OCP servers in the world today, if I measured the total amount of servers that are coming out of manufacturing today, what percentage would OCP be in terms of that server penetration? Anybody? Yeah? Anybody else? We've got some Wiwwyn guys in here who must know this information. I know we've got Alan over there who knows. Alan here, he gets involved. Put your hand up, Alan. If anyone wants to know about the OCP on the networking side, because we're not really going to touch on the kind of the fibre optic side, that's a brand new company that only started a year and a bit ago, backed by a $10 billion business, and you've probably never heard of it, AFL Hyperscale. Anybody heard of it? There's all this new blood coming along. Okay, it's all starting. So this is important for you get to know these people. Okay, the opportunities on fibre is huge. But how big is that market? I'll show you later how big I think it is. Now, the way OCP works, a member makes a contribution, comes up with an idea, it goes through this review, and then when it's accepted, it just gets published. So you can go on the OCP website and download the specifications and build this kit yourself. You can hack it together in your garage if you want to. But I don't think you'll compete with Wiwwyn because they've got a bigger facility for server manufacturer than you have. Okay. Now what we have within OCP, we have a series of projects. We have the data center project, storage, server, open rack, HPC, high performance computing, interoperability, hardware management, telco and networking. Now this is all very, very new, the way this is moving. The telco project only started last January. And now we've got most of the world's telcos adopting OCP and building out and transforming their telephone exchanges. And the project only started a year ago. So it's happening really fast. Here on the data center project, we cover all sorts of things like the ecosystem of a data center, like the power, the cooling. And there's a sub-project that's just started. And if I could introduce you to this man here sitting in the front. Mark, could you just stand up? Mark Dancy is a technical data center consultant from the UK, and he's heading up the Colo project. There's a subgroup called the Colo, OCP Ready Colo project, and Mark is heading it up because, thanks Mark, make sure you get his card if anyone in this room is from the Colo side, because the Colos need to be thinking about how they're going to adopt this equipment when it rolls in, and you're going to have to make modifications to some of your facilities. Those companies that have done this are winning business really, really quickly, and they're differentiating their services based on that their data centers are ready for OCP equipment as it rolls in. Okay? I would like to see your data center getting involved, because what we need to do is make this adoption easy. As easy as possible. There's these technology principles. If you're going to get something accepted, it has to be more efficient than the last one. It must be toolless. Yeah? And there's all these kind of principles that we follow. There's another principle that sits there all the time, and it's simplification. These bits of kit are a lot simpler than your traditional hardware. An OCP data center fundamentally is a lot simpler than a traditional enterprise data center. A lot simpler. These are some of the members. Milo mentioned them. I'm just going to highlight a few. There's Delta. Delta a few weeks ago became a platinum member. They're a major player. I can't tell you what they do, let them tell you what they do, but these guys provide a lot of equipment into the big hyperscalers. And yet, it's quite interesting, a lot of people have not really heard of them, but they are doing some really innovative work in the hyperscalers. Okay?
So on your first slide, Intel was gone. So you had Intel as a starter.
Yeah.
And then on the Platinum, Intel was gone. So I wondered why Intel was gone, and I see them back here.
Yeah, it keeps changing. I'm going to show you something about the membership changes just in the last year. When I get to it, you'll see there's people move and change, and there's more additions. Another player that's going to be here today do a presentation, Wiwwyn, makes servers. Then you've got here, we've got the gold memberships. We've got Agema up here, again part of Delta. On the switch side, you're going to hear about that more. Notice here, you start to see these boys here. All the telcos are becoming members. All the telcos. What's happening there? Oh, is he streaming it back? He's streaming it back. Now, let's try and position where we are in terms of where this business is going. Now, what this book is about the adoption of disruptive technologies. Okay, it's a really good book to read. And part of it, there's the law of diffusion of disruptive information technologies. And if I can just explain what's happening at the moment, you always start with these innovators and these early adopters. And it works out that roughly that's about 17-18% of the total market. And then you get to this chasm point here, and you get this kind of stall effect. Because these guys just go and do it. They want the newest things, and if they've got a problem with a minimum feature set, they'll write the software or just do it themselves. These are the boys like Google, Facebook, yeah, the big boys. The telcos are sitting in here now. Here, to get across to this bit on the adoption, these guys want a more complete solution. These here are the enterprises who are now starting to do proof of concept on this stuff. Yeah? The big banks, for example. You'll hear some big stories about big banks in Europe adopting OCP Git soon. They're playing with it now. Now, this here is also described as the hurricane period. Because once you hit that period, it all gets very, very exciting. And you'll see lots of people jumping into it. The reason you haven't heard much about it at the moment is because it's been sitting down here in the hyperscalers, and there's very few people in the room who've probably ever been in a hyperscaler data center and know what they're doing. So this is where it's starting to push. And it's happening really, really quickly. When I first got involved with OCP, just doing part-time presentations for them, in January last year, I did a presentation in London at a data center conference, and I asked, who knows about OCP? There was 100 and odd people in the room, and 4 people put their hand up. I've been involved with other events around Europe, and now I'm starting to get 50% of the audience and more familiar with OCP. So the awareness is really ramping. It's really ramping. And where we are now, in terms of penetration, we're in this kind of jump boundary line here. We're starting to jump this chasm, and there's lots of activity starting. Lots of activity. It's very, very exciting, as this man here will tell you, because he needs 4 people to help him just on the projects he's working on. Okay? In colos in particular. These people up here, by the way, if you looked at this as the adoption of telephone handsets, when they brought out the press button telephones, the laggards up here, they'd still be using dial type telephones if they were still available. Yeah? But this is very exciting time right here. And you're starting to see all these new companies starting to form, preparing for this business. Okay? Now what I'm showing you here, it took 5 years, from 2011 to 2016, to get to 88 members in the OCP Foundation. In the last year, this is what happened. Just in 1 year. It took 5 years to get to 88, and it took 1 year to go from 88 to 200. This kind of explaining what's happening in that membership profile, what's happening. It's very, very dynamic. It's updated all the time. So it's starting to show we're in that hurricane phase. Everybody's getting excited about it. They want part of this. I was on holiday last month in New Zealand, and it's even happened there. I was on holiday, and some companies there asked me to get involved and do some OCP events there as well. I didn't know it had taken off in New Zealand, but this is a company that provides OCP gear in New Zealand, and they've got this on their website. And it's a research project done by IDC about the size of the OCP market by the end of the decade, into that 50%. And they extrapolate that forward to 2025, and the likelihood is it'll be about 80% of the world's market. The market's not going to look like you know it. This stuff's not going to go in on scale into small enterprise data centers, because those small enterprise data centers won't be there. Now, part of this is all to do with, this is open source. Open source means no patents. It's very interesting to look at the market and see how many of these large historical manufacturers, and they're setting up what's called patent pools. Because some of the technology from their hardware solutions are being used in the open source solutions. And their survival, if they can delay this a little bit and get ready for this rapid change that's occurring, they get some money out of it through the patent pool, but also they can prepare themselves by delaying this take-up. But it's just not working, because what happens is, if there's a proprietary element on a patent on hardware, the software engineer just writes a software instance of the hardware and puts it in in software space. So it's almost unstoppable. You'll hear people talking about network function virtualization later. And it's a very radical thing where you take a physical box that's proprietary, doing a network function in a box, and you create a piece of software that floats above hardware across the infrastructure, the physical infrastructure. Consequently, it commoditizes all of the hardware. And you go towards open source. Now this is it's more than just our industry. Tesla do not have any patents on their cars. This is really radical. It's a radical transformation, global radical transformation. And the most successful companies are moving in this way. Here there's a presentation by one of the founders, Frank Fikowski, of the OCP Foundation, and he talks about the philosophy behind open and why it always wins in the end. And he gives you a historical context. Very good video. If you want to know more about the way the world's changing around you in the macroeconomic sense, read this book. This book is all about collaborative commons, the end of patents, the way the world's changing. There's a radical thing going on at the moment, really radical. This is a very good book for you, and it's about the end of the enterprise data center. And when I talk about the end of the enterprise data center, I'm talking about those data centers. If I went back, say, 10 years, 80% of all the equipment cabinets in data centers would be in data centers with less than 50 racks. Moving forward, you'll see 80% of all the racks in data centers are going to be in data centers bigger than 120, 144 racks. Those enterprise data centers at that bottom end, and if you've got a lot of business in that bottom end, you need to look at what you're going to be doing. Now the good thing is, there's a great opportunity for colos. Because even the big enterprises that start adopting OCP often want colo to house the equipment. So there's a huge opportunity for colos. But there's no future in enterprise data centers at the small scale. You're going to get micro data centers at the edge. That's something different. Now what I'm going to try and show you here, this is a typical traditional server rack. It's got 40 servers. And I'm just going to show you what OCP does to a conventional rack. The things it takes out. And hopefully if my button works. They are top of rack switches. You've got 3 top of rack switches. You throw 2 of them away. And the reason you throw 2 of them away is because when you start to get to scale on an OCP installation, you don't have more than 1 Ethernet interface on the server. You also don't use out-of-band Ethernet management because it comes through the bus bar on the back. Okay, now this is where you need to start talking to these experts in the room who can give you more detail. But this is radical. I've just thrown away thousands of pounds worth of switches, Ethernet switches. Another thing is, there are no power supplies. There are no AC to DC power supplies in the IT kit. You throw them away. These are these little red things. You just throw them away. And typically what you'd see in every piece of IT kit, and we had a discussion earlier, you'll see 2 power supplies running at 2N, running very inefficiently because you're running them down at like 40% utilization. They might only be 80% efficient. OCP does it different, you'll find out today. So you just throw them away. That little thing I just threw away there, that little round thing, these things here are 40mm fans in 1U servers, traditional 1U servers. It's not a very clever way of doing things. You'll understand why, but we throw all those 40mm fans away as well. We throw them in the bin. We get rid of them, and all the power supplies. So we get rid of that lot. Now what you've got at the back here, in the back of the rack, is 4 intelligent power strips. We throw those away because we don't use them. These are AC power strips in the back of a rack with a kettle cord in and IC cord. Plug in 2 interfaces onto every switch and every server. We throw them away because we don't use them. Now, what's interesting, these intelligent power strips here, just throwing away 4 of them, is probably somewhere in the region of, it might be 4,000 to 5,000 euros thrown in the bin. Don't need it. This is why you need to understand the ecosystems. Don't just look at the server in isolation. Don't just look at the switch in isolation. Understand the impact it has on the whole data center. Now, in the back of a traditional rack, you'll have all these cables. This is all the spaghetti normally in the back, because everything's interfaced on the back. You throw those away as well, because it's not there. Then it impacts the cooling. This here is a downflow crack unit, computer room air conditioning unit, using mechanical chilling refrigeration. You don't have that in an OCP optimized data center. You get rid of that as well. And the way that works, it pushes the cool air under the floor through all those cables up the front, and that's the typical enterprise data center system. Well, I've chucked the crack away, so consequently, I don't get the airflows under the floor. And then I throw all the cables away under the floor, and then I throw the access floor away because I don't need an access floor. You can make this work on an access floor, but it's not the optimal configuration. Okay? You just throw it all away. Don't need it. So a typical OCP data center, the white space is you just bring the racks in and drop them on a concrete slab. It's cheap, it's fast, it's extremely cost effective. And then I'll throw all this away. I'll throw 2 top-of-rack switches, I'll take the pluggable optics, which are expensive, throw them in the bin, 86 power supply units, 208 40mm fans, all the power cords, RJ45 cords, I'll chuck away the crack units, I'll chuck away the access floor and all the cables in the floor. In a large OCP data center, there are no copper permanent link cables between the racks, it's all fiber. So if you're in the structured cabling business, if there's anyone in structured cabling here, you need to kind of be thinking about your future. If 80% of your business at the moment is doing copper structured cabling in data centers, there isn't a future. So it kills all this kind of stuff. It kills like centralized UPS, access floors, complexity, hardware redundancy, because you use software to create resilience. You don't necessarily do hardware redundancy in the same way. You save money. If I took you back to that rack configuration, that 40 server rack configuration, if that was a traditional rack configuration that had 5 kilowatts load on it, traditional in an enterprise data center, and I converted it to an OCP data center using the Wiwwyn product that's in here, based on London electricity prices, my annual electricity saving per rack per year will go down by £5,000. So if I've got a 100 rack data center, that's £500,000 a year electricity saving just on a 100 rack data center. It's hugely efficient. It's hugely efficient. Okay? That's 30 minutes, isn't it? Yeah? Now, I'll go through this quickly, but why we use 19-inch racks? We use them because we used to use electromechanical relays. This is what we put in racks today. This is a hard drive. This is an OCP rack. Now, on an OCP rack, the vertical rails are slightly wider. You can get OCP traditional 19-inch EIA solutions if you want them, but if you want to optimize, you use a slightly wider rail. The physical cabinet volume is still the same. All you've done in OCP, moved the rail slightly wider. Consequently, if I look at how it optimizes the volume, the space within the rack, this here is 4 inches across. I get 1, 2, 3, 4, 5 of these hard drives across the rack. Now if that was a 19-inch practice, I only get 4. By just widening the rail slightly, I increased the quantity of hard drives by 25%, and yet I've not increased the volume of the rack at all. So you can get much higher power densities in these racks because you get much higher equipment densities in them. Okay. I'll just put a little note these green touch points. Because it's all toolless, you just have a green touch point. When you go outside and play with these racks afterwards, you'll see these green touch points. You don't need to read a manual. Just touch the green touch point and what it is you want to pull out comes out. Toolless. All operated from the front. You don't go to the back. Now, I told you earlier that it was probably due to relay racks that caused the 19-inch practice. I found this the other day. It's a cartoon, and it just so happens that the frame size in a beehive is 19 inches. So perhaps it comes from a medieval thing, from beehives centuries ago. But it's not a sacrosanct thing, 19 inches. When you look back, you can just do it better. And this makes sense to me. I've got a module and I want to put it in a container. I look at the module and I make the container to fit the module. We've been doing it the other way around in data centers for so many years, and I'm a culprit. That's why I had my eureka moment when I went up to Luleå. This makes more sense to me. You can go and have a look at these afterwards. It's a review of the server. Fans. Typical 40mm fans you might get inside a typical server. When you see these servers, you'll see in the back they've got these 80mm fans. That's the reason why the OCP open unit is not the same as a traditional rack unit. It's bigger. Okay. Luckily we've got some really good power people in the room and mechanical people, and most people will understand the fan cube law. The fan cube law states if I've got a fan spinning, the power to spin it at that compared to halving the speed, if I halve the speed on the fan, I reduce the power to spin the fan by 7/8. It's called the fan cube law. So if I just make the fans a bit bigger and spin them a bit slower, I'll get massive efficiency. How many of these fans did I take out of that 40 rack data center? Probably about 200. Just to get your head around the power efficiencies, this here is about 1/10 of the power just to push the air through the server compared to the traditional method. It's just thinking differently. Another reason why the rack unit is a bit deeper, a bit taller, is because you can get bigger heat sinks on the CPUs. And you put a big heat sink on the CPU and it's easier to get the heat off. The more you cram down onto the CPU, the more difficult it is, the more energy you need to get the airflows. Wire cabling interfaces on the back of servers, basically because a server, a traditional server, is a desktop PC that you put on a shelf and slid into a rack. That's why they're there. That's why we do it the way we've been doing it all these years, because that's what we did. Well, this is no OCP. Let me demolish it. No power supply units, no AC input, no out-of-band management using interfaces that you're used to. Traditionally, in a server, you'll get about 4 Ethernet ports just on the operational side. Well, on an OCP server at scale, there's 1. And it's not on the back, it's on the front. When's the last time you plugged a keyboard, a video, or a mouse into a server? You just don't do it anymore. So an OCP server, they take out all the graphics element. They just take them out. Even though that graphics element has not got a VDU plugged into it, like a visual display unit, it still uses power, still costs money. So you just take them out. And the only thing you really get as an interface is you get an interface on the front, which is 1 Ethernet port. And then all the servers and all the hardware that you plug in just clips onto the DC bus bar at the back. bit more description. You're going to see this stuff luckily here, bit more description. Go on it afterwards. Why do we use access floors in computer rooms? This is why we use access floors in computer rooms, because water flows downhill. And you think, what's he talking about? Well, what I'm talking about is this is a mainframe room, and these are mainframes, and they were water cooled, they were liquid cooled. And if you run the water pipes over the top of the mainframe and there was a leak, it used to destroy the mainframe. So it made sense to lift the mainframe and put the water pipes under the floor. And then we kind of evolved. We thought, we've got this room, we take out the water-cooled mainframe, we put in an air-cooled unit, and we say, well, we'll blow air under the floor. If you do that, it's a very, very stupid thing, even from basic physics, because you're taking no account of air buoyancy. If I've got a warm room, it's more efficient for me to just drop cool air into that room than it is to blow the denser air up into the room. It's better to pour the cooling air in through the roof. Why have we got tight control on humidity? Because we used to have printers in the room, and if the humidity range was too high, it used to curl the paper and they used to jam. And then we also had people in the room. And we used to have these exposed magnetic drives, so humidity was an issue on those. But we don't get these in data center rooms today. We just don't do it. It's a big no-no putting that in. The air quality, the humidity range around the actual mainframe, were we bothered? Not really, because it's water cooled. And we just keep doing this. And the OCP guys, they just, when they started reinventing it, well, they said, this is silly. This is a typical data center. 2 centralized UPSs, all the chiller systems, OCP data center, takes the chiller systems out, no mechanical chilling, takes out the centralized UPS. Much, much simpler. And then what you do, you distribute lithium ion into this, called local energy store, and it goes in the rack. So you've got a rectifier unit in the rack, lithium ion store. It's much more cost effective. It also creates a lot more resilience, because when a UPS function fails within a single rack, it doesn't matter because it doesn't take out the whole data center. You don't do rapid break fix in OCP data centers. You don't need to. The software can manage it. The OCP data centers that Microsoft use, they might not go in to do a hardware fix for 9 days. Something breaks. Typical enterprise data center, an item breaks, you rush in like crazy. Just to get your head around the efficiency on manpower, in an OCP data center at scale, the support technician ratio to physical server goes up to 1 technician to 25,000 physical servers. In an enterprise data center, even the best, you're going to see a ratio of about 250 physical servers to 1 technician. Now what that is, it's a reduction of 99% on people. So it's not just energy efficient, it gets rid of that cost overhead, is people on 2 legs. It annihilates that overhead. So this is just kind of describing. Another thing is, in a traditional enterprise data center, every rack is infinitely different, so it's very complicated. Over here, this is an OCP data center. If I told you about Facebook have over 100,000 equipment cabinets, millions of servers. They only have, I think it's 7 rack configurations. It's just so simple. No tools. I like this one because it had a lot of mention of Philips in it. And I thought that's a very Dutch thing I could bring in, and I like that's Philips' head down there on the slab, but never mind. But no tools. Now if you can spend just a minute and read this. Just read this. How long have I been going for? Got 5 minutes left. Just read this. Now, I love this. This is I wonder if the rope is really necessary. And this is because you create resilience. You don't use the hardware redundancy in the same way. You use software to do this with the hardware. And you must begin to understand this connection with the software. The way software is changing the industry is dramatic. Give you an example, mentioned it. We had a very good discussion earlier. I mentioned the way software eats hardware. As Facebook was scaling out their hardware, the vast majority of the servers in their big data centers are the front-end web servers. They were scaling so fast, they just couldn't build fast enough. So they gave the problem to some software engineers and said, make this interface, make this process work faster. And they developed, using a new programming language called Hack, they create something called a hip-hop virtual machine. The consequence of the hip-hop virtual machine reduced the requirement for front-end web server interfaces by 80%. The transformation from virtual machines using VMware type hypervisor heavyweight virtual machines, for those that know, compared to a Linux machine, that can potentially reduce the hardware by 66%. Software is eating the hardware. And you've got people in this room who could give you a 15-minute on what's really happening. And the reason it does it is because you unbundle this commoditized open source hardware and you float these instances above it. And hopefully these guys will explain more how it works. So I don't care if I lose a piece of hardware, that instance can go somewhere else. It can go somewhere else in the data center, or it can leave the data center and go to another data center. Now I'm just going to bring this up because this is what's causing an issue in the industry, that this approach is undermining the traditional hardware redundancy approach that we've all worked with for years. The key is resilience, not hardware redundancy now, because we're bringing in software. And I would love people to kind of work with me, because I'm talking with the uptime, because we're trying to resolve how we can bring software into the model to create the new structures, the new guidance.
What you can do is go to the green grid and go to the OSDAP project, because there we're addressing all of these things.
Yeah. And I'd love to kind of work with people to bring it together, because it's quite complicated. Yeah. We need software engineers on this modeling now to understand what's going on. And that's unusual. Normally we have all mechanical and electrical engineers that work on this stuff. We need software engineers to explain how the virtualization systems are working. Okay? This is a big discussion topic that won't go away. The over-the-top hyperscalers took it, the telcos are doing it like crazy, they've got to be finished quick, and the enterprises, and now we're into this kind of the hurricane phase. And it's very, very exciting. What I'm trying to show here is there's a butterfly coming out of a chrysalis. If you don't change, you're going to die. Very good book, Willful Blindness. It's about, if you ignore the obvious, then it could be a very perilous thing, yeah? To stay with. A very good book. Now this here, I'm not going to play it, but it's Menno's going to touch on this. It's about Yahoo Japan. They did a case study at the last OCP summit in America, and it's brilliant. And once you get this, make sure you look at these presentations. There's over 200 videos, I think, now on the OCP YouTube channel. This is how I learned when I first got into this, I looked at every single video, and that's how I started learning, because there was nobody in Europe that could tell me anything. Now, what I'm doing, I'm killing your babies in a way. So what this is, the Kubler-Ross curve, performance over time. If someone dies, you go into a series of, you go into a shock phase, you go into a denial phase, you get angry.
Or happiness.
Or you could do. That's brilliant. You could do. But you go through these emotional turmoils. And then eventually you get to an acceptance phase that it's happened, and then you'll start living your life again. And all I say is, I hope I leave you here. Right? That's where I want to leave you.
It's not possible.
That's where I want to leave you, and we just go on, and that's basically it. Now, loads of questions later. Please send those emails in with questions so we can hopefully answer them today. If we can't answer the questions, we'll get together and we'll make sure that these answers go out.
Well, I think at least there's an observation where you say that the corporate data centers will be completely gone. What we see actually now is hybrid cloud coming back. We see that the smaller data centers coming to the co-location area. I underwrite the point where you say we remove a lot of nonsense like UPSs and other stuff. Where actually, when they come to co-location, they want to have it even closer to speaking uptime language, closer to tier 4, because we are sitting on the carrier dense networks.
You are.
So from that perspective, we see that they built their, let me call it, data crunchers outside. And then they connect to the co-location, and there they want to have it very highly connected and very high availability and reliability. And then we see, first of all, we see the hybrid cloud now coming back,
yes,
from cloud to hybrid cloud.
Yeah, yeah.
And I think that that's an observation. The other thing we see as well is some of the large players, they even go back to bare metal. We now see, for instance, Oracle, they say, hey, we start now with bare metal. We believed some years ago that bare metal will be dead. We never believed bare metal would succeed. We saw companies really running bare metal, and we thought it will all be cloud. But I think it's because of the legislation on data protection and everything that you see, let's say, bare metal companies finding their way again.
It's changing. It's really changing. If I can just leave it that it is changing, the discussions can go on and on. In this room, there's somebody I'd want to introduce you to about that last topic that you mentioned, because there happens to be someone in this room who knows a lot about, and I'll get you talking to them. Everybody happy? Yeah? Yeah, can do. Let me just ask about timings. I've still got 15 minutes. Yeah, questions if you wish.
On the organization, I mean, it's a lot of time you can just open source your design here. There's no process of coming to an agreement of a design, right? So it's like if you Facebook said, look here, that's how we do it. They say like it, that's how we do it. So yeah, just a gathering of a lot of different designs. Everybody does it a bit different, and
they do.
Is the best, right?
Yes.
So there's no process of convergence from an open compute project perspective. Market is doing it.
Yeah. Now, what's interesting is this, and I must, because lots of people that have been in the data center industry for a long time, they're used to standards. OCP is not a standards body. It's a place where people come and commune to develop open source solutions fast. And you're dead right. It's not going to converge on a single answer, because the world doesn't want just a single answer. This is where you're going to see more variety, and you need to change your mindset. If you think linearly, that you think in step by step, if you're a list thinker, you'll be no good in the future. You have to be a mind map thinker in the future, because when everything comes connected, if you're thinking linearly, you cannot solve problems. Disruption does not go in these linear stages. What we've been in historically is these linear steps, very, very simple steps. There's a major disruption occurring. You have to change the way you think. And if you want a good book on that, by the way, I love recommending books because I read lots of books, is a book called The Power of Habits. Really quite good.
Could you explain the IPR rule again?
All I say, in terms of, come and talk to me afterwards, and I'll send you to a massive information. But basically, it uses an open source specification that was developed for the hardware, similar to what, the Linux Foundation use. Yeah, and you can write, if you wanted to, you could write some code to do some hardware management, submit it into the community, and people think, how do I make money by doing open source? This is what people can't get their head around. But if you look at the stock prices of the proprietary people, the proprietary companies, and look what happened to them in 2015 and 16, their stock prices going this way.
I would disagree on that. Heavily.
Talk to me afterwards, and I'll show you some stock price figures.
You can always find an example.
You always find an example.
You can, but because we're on video, I don't want to mention one particular company because I'm being videoed. But I'll talk to you later about some of the big vendors that you know and love, and what's happening to some of the big vendors you know as hardware companies are transforming themselves as software services business. That's very, very disruptive. I'm not going to say it on here. I'll talk to you later. Okay? They'll sue me. No. Any other questions?
John, I really like your presentation.
Thank you.
The feeling I have is really like what you said. You leave us in a depression, and I have a lot of fear. Because if this is a revolution, it's a paradigm shift. How do the current society and enterprises, telcos, all the segments that you mentioned, deal with it? I think you were mentioning a lot of people, 99% of the people will lose their jobs because of the power efficiency. Everything will be so efficient, but this is still a human society. How do the industry react to that?
Now, I take the point. When I'm talking about the people that you're going to need in future data centers. It's going to be a drastic reduction. But what's really exciting, when I started the presentation, I said there's huge opportunities and there's not enough people who know how to do this. For example, if you know OpenStack, there's such a shortage of people who know OpenStack, and this is the software that kind of manages the virtual kind of management of the instances. So there's going to be huge opportunities in building out the infrastructure. And if you read that book that I recommended further back called The Zero Marginal Cost Society, it actually takes you into a much deeper transformation of society, that we're going into a new industrial revolution. And in this new industrial revolution, there's going to be huge build out of infrastructure over the next 10, 15 years. So there's going to be huge job opportunities, but they won't be like the job opportunities that you used to. But if you go even further forward, the head of the Economic Forum wrote a paper recently, very concerned about job prospects when we get into this automation in 15 years' time. And if anybody wants to read it, drop me an email and I'll send you it. I only read it this morning. My wife sent it to me. And the future, 15 years on, where you want to be. If I'm going to give any advice on a job that's the best job, become a coder. Get into software. Get into software. But it's really profound, definitely. But I'm very, very optimistic. And I'm optimistic because it's becoming a collaborative commons. There is a change occurring that I think is really fundamental. And again, you'll see it in that book, the Zero Marginal Cost Society. And it's thanks, the men don't ask questions like this, do they? They don't. Yeah. So well done. Yeah. Okay? Thank you very much.
Now, make it Menno a few times in presentations. How Menno do this presentation. So Menno will give you an idea how you implement the OCP solution in real data centers or even in server rooms.
Can you throw that down there?
Should I see if this thing works? Yep. Why it's working? Is this okay? Yeah. Okay, good. So welcome, shocked people, I think. First of all, please, if you see something nice today, please share it. You're welcome to take pictures here. The rack is just outside, as mentioned. Please take selfies or whatever, tweet about it. And so, yeah, this is me, Menno Kortekaas. My email address, menno@circleb.eu, if you have any questions after this. And I'm going to show you a few cases of OCP implementations, as was mentioned by Milo already. And yeah, what CircleB does is we try to promote the 21-inch OCP standard in Europe. That's the one designed by Facebook, because we think that is the most innovative thing. We provide OCP-based solutions. We provide data center with partners, and with the rack and power, the server, storage, network, and services are the building blocks that we use. So yeah, why OCP? Because we think it's the next step in the evolution of the data center. If we look at traditional hardware design, what we've already seen is, for example, this is where the BIOS battery is. And it's actually behind the network card here. So traditional design is, it's not easy to do maintenance on traditional servers. We do see something that we recognize here is the logo of where we are today, Delta. But actually we see it's also some of the fans are missing. So I don't know why, but it's like not really properly cooling the network card here. So these are some pictures. I just took them a few weeks ago. I was visiting a data center and I saw this, and yeah, I was reminded of John's presentation, so I took some photos here. Also the connectors, well, they're not even being used. It's keyboard, USB, serial, a monitor, some USB here as well. Nobody's using it. Even one power supply is not connected, probably broken. And well, everybody ready? This is what the whole rack looks like. Yeah, and this is in Equinix AM1, so you can check this one. It's very close by. It's, well, yeah, no words. So yeah, the hyperscalers, the big companies, they know that this doesn't work. This doesn't work at scale. But they know how to hack things. So a bunch of Facebook guys decided to go to ASUS in Taiwan, basically to start learning how to build your own hardware. And yeah, these guys have this mindset to always be open. This is a sticker at the Facebook office. So as John mentioned, they open sourced their designs. They started the OCP Foundation in 2011. Founding members Facebook, Microsoft, and Rackspace. And maybe this also answers your question. You can get involved. So there are different project groups. I think this is the network one. And you can get involved here. There's mailing lists. You can subscribe to it. There's a wiki page. But they also have these monthly or like scheduled calls that you can get on. So you can really, maybe not influence, but learn or adopt something and change it for yourself, and then upload that design again. So that information is all here. So the OCP design here that we promote is a rack scale design, because you start with a rack, the 21-inch rack. And after that, everything is very modular. So the rack is the first module. The power shelf is the second module that we see. Then we have the servers and storage devices. And even inside of these devices, it's modular. So inside here we have, for example, this board. This is a SAS board that can be replaced individually, can be upgraded maybe from 6G SAS to 12G SAS. There's a lot of modules inside of these components that can be changed. You can see it outside. It's serviceable from the front, as already explained. Just need to be on this side. More convenient than the hot L. And it's toolless. And notice the fan over here was already mentioned by John. There's a lot of innovation. So this is the lab. You see, this is the new wedge switch, some servers. This is a power shelf, storage. This is I think this is the Facebook backpack, and what we call a cubby to put servers in. Yeah, and obviously a whole rack that they're doing some. I think this is some machining or testing. I don't know. And there's also green materials. I haven't seen this anywhere else yet. They use natural fibers combined with sort of plastic, and they use it for these plastic components. We have some of these in our rack, for example. We have this on the Honey Badger. It's quite innovative. I haven't seen it from any other vendors. So the web scalers, they think big. Was mentioned by John. They have this very few type of racks. They do have variations in these because of like multiple generations, but this is basically the sort of racks that they have: a web, database, Hadoop, haystack, feed, and storage. So different rack configurations. And in closer look, so what is the Type 4 rack? Some storage, storage mixed with compute, and a single switch on top. Type 3 rack. I think this is using more power because the compute with the flash, they left out the middle part. So it's probably using more power than the power shelf can handle here. And as mentioned, they write a lot of their own software. It's most of it is on GitHub. Also the HHVM, it's on GitHub as well. But they also work on integrating with other like well-known software. So at the OCP Summit, it was announced. I'm not doing anything. It was announced that also NetApp and there's other storage software as well that works on the NUX storage and with the Leopard servers. So it's something that we have here outside as well. These components. So they're trying to promote adoption also with well-known software. This was also at the OCP Summit. Yahoo Japan. They presented their how they implemented OCP. So they're running in Japan OpenStack on this Wiwwyn gear, and in the US Hadoop, OpenStack, and Kubernetes. They did some testing. You can see it in the video. This is a capture of what they showed at the OCP Summit. They tested the serviceability, and this is the time that they recorded to replace these different components. And we see here the CMOS battery. It's actually, if you look outside, you pull the server out, and you can reach it from the outside. So the CMOS battery is very, very easy to replace, and this just goes deeper into the server. Like the mezzanine NICs takes the longest time because you have to take off the hard disk carrier, and so this is the component that takes the longest to replace. Then when we look a little bit smaller at edge and regional data centers, so going from hyperscale to sub-hyperscale, this is kind of the sub-hyperscale is the market that we target as Circle B. So the telcos, they really start to like OCP because they have this drive to go to network virtualization, network function virtualization. They're going through something called CORT. It's a central office re-architected as a data center. They're working on MANO, Management and Organization Working Group, part of ETSI, which is a framework for NFV. And there's the Telco Infra project, as John mentioned, a spin-off of OCP. SK Telecom also presented at the OCP Summit. And as you can see, they're already a bit smaller. Like Facebook has hundreds of thousands of servers, as John mentioned, and they have less than tens of thousands. So the scale is getting smaller, but they still they tested it. This is their test bed, legacy rack on the left side of the corridor, and here's the OCP rack. And what they show in the presentation is also what John mentioned, the efficiency of the fans in OCP. And they noticed this decrease. So depending on the workload, at 100% workload, they noticed this decrease in power consumption, which is quite significant. When we get to clouds, which is probably more common for us, they tend to use automated provisioning and on standard hardware, such as OpenStack. This is kind of what you need, and this is the building blocks, the compute, networking, and storage that we provide. And you can run your application on top of like some kind of layer in between that provides this automated provisioning. This allows you, as private cloud provider, to compete against the public cloud using open source software on top of open hardware. One of our customers is Arctic Circle Data Center. They gave us this quote: "The Open Compute project allows us to use innovations of companies like Microsoft and Facebook, being able to purchase from multiple manufacturers hardware that works according to a common open specification, avoids lock-in, and is very reassuring. When planning for growth with homogeneous hardware, OCP is a natural choice." I will show you another reason why this is a natural choice, because they're really in the Arctic Circle. So they are here. Facebook data center is somewhere in Sweden, I guess around here. Yeah, you can only get there by like a very small airplane. It's not really a place where you're going to ship a lot of engineers to. This is eventually the site plan. This is what it will look like, but now it's a brown field, so they've planned for this, got all the permits, and they're now using a colo facility in this area. So initially, this is what we proposed to them. This rack layout. It's based on OpenStack and Ceph, and they recently finished testing on this proof of concept rack. They do all their own deployment. Their automated deployment is all built by themselves, so they do a lot of software things, but no hardware. And they are now on expansions of this proof of concept. They're onboarding their trial customers. So they have customers that are running on this OCP hardware as well. Then in Amsterdam here, we work with a data center called Switch Data Centers. We have this is just last week, we put one of our OCP racks in the data hall that's completely suitable for OCP. Circle B is here to help, so you're not alone. This is the Circle B team. Obviously, me and Niels is over there, and Megan over there. And we provide these services: design, integration, pre-cabling, burn-in testing. We make everything ready for automated deployment, so you can roll the rack into a data center, plug it into the network, use Pixie, give you a list of MAC addresses, for example, and then if you do the automation, it deploys it itself. Or we could install an OS for you and do the services and consultancy. This is one of the racks that we have built in a testing, burn-in test, I think. We can provide support services as well. And you can find us on social. We're quite active on Twitter. Facebook not so much. We have a YouTube channel. I hope everyone will subscribe so that we can get to 100 subscribers and we can get a proper link. Or you can go to our website. What's next? Trying to build a little bit of a community and get people involved and keep them updated. You can visit us at Computex in Taipei. That's in Taiwan. We'll be at the Wiwwyn booth. It's in the TICC building. And that's it. Hopefully you have questions.
You mentioned the telecom infrastructure project.
Yeah.
Could you elaborate whether there are sort of two groups which sort of do something similar, or probably I misunderstand that they don't do something similar, but could you elaborate on that?
So what they do similar is that they're working with OCP and they're trying to adopt certain aspects of OCP. For example, the rack, but with some modifications to telco, specifically for telcos, such as fire resistance or air filtering. So the OCP, like the OCP server itself, in the specification, you can use an environment temperature of 35 degrees, up to 35 degrees, yeah. And that's kind of what telcos like, because they have what's called the central office, but it used to be like where all the copper cables converge, and it's not really built as a data center. Mm-hmm. And you don't need you don't really need a raised floor. As John mentioned, all the cables go in from the top, and it has wheels, and you can place it like anywhere you want. And some aspects are really liked by telcos, which they cannot find in traditional gear, but they need to move to this network function virtualization. So they need servers, and that's why they are adopting OCP standards, like the OCP motherboard, the OCP rack, and making extra additions, modifications, like even more seismic, like what I just mentioned. So they're making additions to it. And that's what they're doing in the working group. They're also working on other stuff that's maybe not really needed by the hyperscalers, such as their own CWDM equipment. And yeah, some of the fiber stuff that in a data center we don't really need, but the telcos need it.
You largely talked about the telco project within OCP.
Yeah, it's a sort of a spin-off from OCP. Yeah, it's a separate group of telcos that work on like their telco-specific stuff. And so that's where they make the modifications and they discuss, because really if like one telco in Germany, they probably have the same requirement as a telco in the US. So it doesn't make sense to start making your own design. They can make the design together. So how are we on time, Milo? Yeah, enough? Okay.
Any other questions?
Yeah, I have one.
Yeah.
But, don't want to. You mentioned the SK Telecom example.
Yeah.
Which is sort of like smaller. What would you say is sort of the smallest data center you would still sort of, or where's the break even from traditional to OCP, starting from what size on?
Well, everyone can adopt OCP and you can start benefiting directly from the power saving. It just won't be as much as when you're working at a big scale. But for us, because we are in between the manufacturer and we're providing the whole solution, we don't have a minimum order quantity, but it's, well, you cannot do like less than one rack because you need the rack with in the 21-inch standard. We also have 19-inch servers, but then you're going back to like 1U with the small fans, etc. So we think that's not really that big of a change, so we don't really promote that, but it's possible. We have the similar motherboard in 19-inch. But if you want to do 21-inch, you need to start with the rack. So one rack is the minimum, and then you probably want to have like not have 3 servers in it, but almost full. So that's how we can help you to start with OCP.
What would be the maximum rack load for the telco?
The weight?
No, in kilowatts?
Kilowatt depends on the power shelf. So the power shelf that you see here is 12.5 kilowatt, but we can do 2 zones or higher density power shelf. So 2 zones you have 25 kilowatt or higher density power shelf. Yeah, something like that, like 30 kilowatt maximum probably.
For open rack, we are pushing up to 33 at the moment, and now we are expecting to have a higher power range.
Yeah. I don't know if there's anyone here for telco who can explain it better than me or Milo. You want to add something?
Okay, we could discuss it.
Okay, yeah, we can discuss it later. Yeah.
So any other questions for Menno? Hey.
So, well, yeah. How much time do we have?
Yeah, we are perfectly on time, so if you don't have any questions, or you want...
Well, I was thinking to ask, like, after seeing this, what's the feeling? The shock from John? Does it help? I don't know. Or still? Maybe you have a question? Oh, sorry. Yeah.
Actually, it was no shock, but you actually underwrite my feeling. But basically, let's say, so it was not a shock, first of all, because I think you believe there's a lot of ignorance in Europe about OCP, which is not really the case. But on the other hand, what underwrites your story is that you would have a one-rack OCP. So you will have a small enterprise with its own OCP connecting to whatever he wants to connect.
Mm-hmm.
So where the discussion was about enterprise, that's history. What I mentioned already earlier, that will not be the case. I'm looking at hybrid cloud as well for enterprises. Basically what you're saying underwrites this as well.
Yeah. Yeah, so we could start. We're planning to build out the OCP racks in the data center that I showed. So that's also where we would like to provide from like a single rack in a colo facility as a starting point. So that's kind of what we want to make it kind of as low level as makes sense. I think there was another question. Or okay. Yeah.
Maybe I have a question. What, if any, would be the benefit for companies that have not embraced the microservices web scale architecture and are running more kind of a legacy enterprise application?
Yeah. So if you didn't adopt the microservices, well, the gear it comes as a like a bare metal or just a regular server. What's not there is such as fiber channel storage devices. But there are several. Facebook demonstrated last year at the Technology Day how they are running GlusterFS, for example. And this year they've added NetApp ONTAP, as well as another well-known storage vendor's software on top of OCP boxes. So there are possibilities, but it's something that we need to look into. Also, VMware, for example, is supported by Wiwwyn. Windows is supported, and a lot of different Linux variants. Red Hat, the other one was it from Canonical, Ubuntu. They support it from Ubuntu side, from Canonical side, and from Red Hat side. It's fully supported. So they verified that. And then, yeah, either your own software, or we'd have to see if there's something already supported and available. Yeah.
If I can just mention the laboratories for the software compatibility, the one in America and the one in London.
Yeah, so Facebook, because they would like others to adopt, they have a verification lab in the US, in Menlo Park. Their main office is where they test these other vendors' integrations, such as the NetApp integration. And in London, there will also be a lab based on 19-inch equipment where people can test software, see if it runs. Probably will run, but you just want to know. And we also have, at the moment, we already have a setup, but it's not in the data center. It's in our office, where we can provide remote access if you would like to test something on an OCP server. That's possible. Yeah, that kind of like lowers also the threshold.
Okay. Any other?
Yeah. Any other questions? Like we would like to have maybe a discussion like we're having. Or should we go for the lunch break or toilet, bathroom break? Okay.
Thanks, Menno, for the presentation.
Okay.
Before the lunch break, we arranged a short tour of this building. I just want to let you know that this building, actually, I'm the project owner for the renovation. We bought this building a few years ago. At that time, this building is with energy label E, and it's not accessible by Delta Corporate. So we initiated the project to make it energy label A for this building. I will show you, give you a short tour around and show you how we do this for certifying this one as a green building with a very efficient energy consumption, and also give you a short tour outside. Okay. But I will let you have a short break. So we will start the tour at this reception area around 11:30. Is it okay for everyone? Okay, then let's start.
on this chart that you can test your software on. So please feel free to contact us if you really just want to dive in OCP right now and have it available to try out your software. So with that, let me try to now show you a live demo we've prepared of when we went into RSD. So, well, actually, Menno, would you please play the video for the audience?
Yeah.
Okay, great, thank you.
Wiwwyn. In the community of Open Compute project, all the members are looking forward to embracing prosperity from sharing and synergy. For years, Wiwwyn has been carrying out commitment as an OCP contributor, delivering best quality solutions and latest infrastructure technology in the spirit of Open Compute. Wiwwyn achieves the highest level of IT workload optimization for today's data centers.
Hi, Menno.
Although modern development of cloud computing allows server virtualization on a physical node and resources, such as CPU, storage, and memory, this could fall short for some applications, while others are excessive in utilization. Some applications are more computation power hungry, while the others are in need of storage capacity. Hence, the demand to flexibly compose a node with extensible resources has grown to address the resource optimization. As a leading hardware provider and OCP solution provider, Wiwwyn has been working closely with Intel to unlock infrastructure potential. Intel rack-scale design is a logical architecture that enables scalable pooled resources and maximizes utilization. Simply put, Intel RSD unlocks resources from physical servers, creates virtual pools of resources, adds physical resources into pools if pools run out, applies resources to application workloads, composes resources, and reconfigures as requirements change. The pooling technology can extend to applications on other PCIe devices in the future. Wiwwyn offers a series of products for OCP and 19-inch racks for Intel rack scale design integrated with Intel Xeon processors. Enjoy the best workload optimization and TCO for your data center. Wiwwyn.
Okay, great. So, all right, to begin, that video was just a brief introduction of what essentially the concept of Wiwwyn Intel RSD is. So let me, what I have here is actually now 4 windows. So you guys see all the 4 windows that I have up?
Yes.
Okay, great. So the first window is the upper right one, and what you want to do, well, the first thing I always want to mention is the RSD interfaces just really need 1 window, but the reason I have 4 up is to give you a better idea of how the story or how RSD works. So the first thing in this window you see is you have your compute pool, your NVMe pool, and your storage pool. And to just briefly explain what the RSD technology does is, in the previous history and technologies, we've really been focused on the virtual machine and kind of its evolution. But what now Intel RSD does is go down to the lower level and it disaggregates on the hardware level, right? So, and it creates pools into a logical compose node, basically your physical disaggregated sources, and turns those into a composed node. So that offers scalability as well as full utilization of your resources. So knowing that, that's why we have essentially, the pools of all their physical resources. So this is running on real OCP hardware right now in Wiwwyn's lab. So we have 3 blades here, 15 NVMe drives, and a storage pool offering this amount of terabytes. Now the first to understand RSD, the first action you would do would be compose a node, right, out of your physical resources. So let me just type, for example, my node 1, and we have a node 1 description here. Give it a description. And this section, you can specify, like a search filter, what are the minimum requirements that you want to search for. So let's search for Xeon E5 processors and search like a minimum of at least 14 cores. And you can also specify what kind of local drives that you may want in case you want a boot drive, but for demonstration, we'll just leave that. And so for remote drive, IQN, let's give it a 3 terabytes. And you can also, yes, specify any VLAN that you want this logical compose node to be part of. So, okay, we'll try that. So, okay, so what we see now is in textual format, we created the compose node. And if you see on the right-hand side, it says 1 blade has been allocated, and indeed 3 terabytes has been decremented from the storage pool. Okay, great. So now let's check out the NVMe thing for this. So we click Attach NVMe here. And we click Add. Let's give this compose node some more power by adding an NVMe. And while this is going on, just do want to mention that this GUI of our Wiwwyn Intel RSD is based on the Wiwwyn Cluster Manager, which is a full data center management suite. So what you see here is really the interface to RSD, but if you use the Wiwwyn Cluster Manager, it has many more features such as notifications and perhaps deployment and various other tools or asset management that you would use in your typical data center responsibilities. So as we can see here in my mouse cursor on the left window, we have an NVMe drive attached in text. And if you look graphically on the right-hand side, one NVMe drive has been attached. So what we can also do is come down here to the console. And if you see, previously we did not have any NVMe drive, but now we do indeed have an NVMe drive attached. So that just further reinforces to show you that this happens on the actual machine. And if you look on the left-hand side, we also have a handy interface, so you can see exactly which NVMe drive is attached to which compute node. So you can, from there you can see how the connections are actually working from a graphical view. Okay, great. So now that we have that, let's try to, let's try to give it a, let's try to give it a second one. Just to show you that you can have multiple NVMe drives. And, okay, so while this is going on. And as well as we also have a feature of, as well as once you create your logical compose node at this time, RSD technology also enables you to deploy any operating systems that you might want to select, which we might expect from this kind of technology. Okay, great. So you see textually that we've indeed added a second NVMe drive, and it also shows graphically. And we should be able to see it here. Okay, great. We see 2 of them down here in the console. Now, with that said, let's try to remove it so we can see how the pool technology actually works. Okay. So what we should see is that textually you should just have one NVMe drive, and in the pool it should be returned the one that we just removed. And okay. So what is going on, like in terms of VLAN, you can set VLAN for your various logical composed nodes. So in that way, it's easy in terms of the network for RSD technology to separate by the VLAN layer your logical composed nodes. So we see now that in textual format, the NVMe has been removed and it has been placed back into the NVMe pool. And if you want to deploy any operating systems on, like, let's say your logical composed node, we have this interface, so you can just select minimal Ubuntu, and you type in your login, and yeah, once you click OK, it'll start deploying. Just show the middle one for demo purposes. And it will start deploying on your logical composed node. And through that, once you got that, you can put on the higher level software layers on top of that. So yeah, essentially that pretty much sums up kind of the RSD demo. And there's just the final message is pretty much that Wiwwyn and our partners, we're really committed to OCP, and as well as even not just hardware, but as you can see, Wiwwyn into RSD, the software side. We are heavily and also deeply partnered to bring this technology to the next step in the software-defined data center. So I hope you guys enjoyed and learned something from all this. And yeah, I guess that pretty much concludes my part of the presentation. And if you guys have any questions at this time, I'd be happy to discuss with you. All right, thank you.
Thanks, Ethan. Any questions to Ethan?
Is this software something that you set up once?
Ethan, is this the software that you just need to set up once for the system?
Yes, RSD software, you just, okay, let me just briefly explain the architecture is, yeah, the answer is pretty much you just need to set up once. And through this interface, you can build logical composed nodes, or you can remove the nodes through this interface. So you don't need to restart this software every time. And this won't affect you don't need to reset any time in terms of application changes. You will not need to reset the RSD software.
Thanks. Any other questions regarding this OCP servers?
Oh, yes?
Okay. So, if no, any question? No. Thanks, Ethan. We don't have any questions. Thanks for the presentation, and we will give you contact.
Thank you. I hope you guys enjoy the rest of the event. Thank you.
Yeah, thank you.
Thank you.
Okay, so next one, we will have Peter to explain the design for the power architecture of the road or 48 volt.
Yeah, so thank you everybody. Yeah, you see the layout of my presentation is not OCP style, so that shows you that I'm a new kid on the block, I would say. Thanks, Menno, for inviting me here and explaining a little bit on on the, let's say, probably not so major focus side here on the power architecture. Actually, what I wanted to say is today's morning I heard a very interesting presentation where all the power disappeared from OCP. So I hope that there's still some power supply providing power to the server. So I'm pretty confident that we still need that, even with all this virtual assignments and configurations. In the end, you will have a server, and this server consumes power, has a microprocessor on it, and needs a power supply to supply this server. So actually, I want to start my presentation a little bit on a historical Okay. Very simple slide. So on the bottom you see, actually, I started here my career, so it's a little bit decade before I started. I was here in high school. So, and what I wanted to say with this slide is that we experienced, as a power designer, different microprocessor input voltages. So actually, I structured this presentation in a way that I look really from the processor back to the upstream. And we started with 5-volt technology on the motherboards. Then immediately we had the 12-volt for the CMOS. And what I recently see here is, I think this is the older version, Menno.
Maybe
I missed one line here. Okay, but I continue. Today we see a kind of a trend for 48 volt motherboard input voltages. So we have customers who already use in data centers 48 volt output power supplies.
Okay, this is the new one.
Yeah, so I added one important line here. Can you go to the next page?
Okay, can you try?
Yes, you see. This is an important line because as the input voltages of the microprocessor boards increased, the processor operating voltages of the microprocessors decreased. I think we are right now at 1 volt or even below. So this is your expert field. And I know that you have a couple of 100 watts of the individual processor, and when you have 1 volt, it's very easy to calculate. Then you have a couple of 100 amps to handle. And this was kind of an interesting development. So we see, like I said, we see now 12 volt is the majority of the mainboard input voltages, and then we have different distribution systems and conversion systems going down to the on board level to the microprocessor voltages. And we are clear focused here on the 48 volt right now for the future. And interesting is when you look to the powertrain, I'm just wondering if somebody really dares and I see a certain direction that we will see on the motherboard also voltages above the 60 volt magic limit. This is the limit between a safety electrical voltage, so it's a voltage which you can touch, to a voltage which you probably shouldn't touch, because there will be maybe one time, or so it's a more dangerous thing. But interesting is really that's what we experience over the decades, an increase of input voltages of the motherboard. Then you do the processing of the voltages and transferring the power on the boards to the microprocessors. Leading then to our assumption here, and this is a slide which I grabbed from one of the OCP events, that in the data center world, today the majority is at 12 volt, and we will see that in the future the majority will go to 48 volt. So I can also sign this off, because when you look to the racks, we handle in this such kind of an innocent rack, 15 kilowatt, 30 kilowatt, and you need to distribute that in the rack. And I have some magic numbers for you. So you know 1 milliohm is a quite low resistance, right? If you have 100 amps going to 1 milliohm resistor, you have 10 watts of power loss. I have later on a quick discussion on the clamps we are using. And if you have a 250 amps, then you have 62.5 watts of power loss on a 1 milliohm resistor. So you have to go below 1 milliohm in the micro ohm area. That's kind of difficult because you have copper, which has a given conductivity, and you don't want to use gold for your contacts too much. So to increase then the voltage in order to decrease the current is a clear direction, and it's a natural direction in electrical engineering which we experience over the since Volta, you know. So that means due to the efficiency gains and higher power demand, strong increase of 48 voltage systems are expected. So that means our load will change in the future. So it means the loads I have to supply from a 12 volt input to a 48 volt input. But I want to rephrase Ohm's law again to refresh everybody's school time. So increasing the distribution voltage, reduction of the number of conversion steps, the reduction of the number of interfaces, so kick out connectors and plugs, and reduce the size of the lengths results in the reduction of power losses, as these power losses are given by this well-known law, resistance times the square of the current. And the resistance is defined by geometrical parameters and the material you are using. And the current which you are processing is defined by the power divided by the voltage. So that means the higher the voltage, the lower the current. So very easy formulas. And when you look to the architectures, and which are used in data centers today, and I'm focusing here on the so-called legacy architecture involving a UPS. So I'm not so fancy and much future looking, because this is architectures we see in good old Germany. So, and also some regulations and standards are forcing us into this architecture. But I don't want to do the politics on this side. I just want to concentrate on the nice rack level. And here for the rack level, typically we have an AC input, and then we have a static transfer switch. We have an AC to DC power conversion, a DC-DC. Inside the AC to DC power supply, we have a power factor correction unit. So it's an AC to DC converter, DC to DC converter, converting them from 400 volt DC link down to the 12 volts. Then you have to distribute this current, which is in the range of a couple of hundred amps, down to the board level. This is here, and then you have the voltage regulators, the VRMs, which are typically multi-phase buck converters, and then you go to your microprocessor. And interesting is, you have from the beginning, from the medium voltage transformer over the UPS, you have power conversion stages, and I counted here 6. So really conversion stages. So the transformer I consider as an AC, and then we have here also the UPS, AC, DC, DC, AC. So in all, we have 6 conversion stages. We have here a centralized battery, but like I said, I don't want to discuss this here. I just want to mention that we have 22% losses in the conversion steps, and especially on the rack level, we lose this is 5, and then another, so this is 5 and another 2 for the distribution, so around about 7% in the rack. And then the point of load converters, which are really giving us a headache. So converting 12 volt down to 1 volt, it's really not so high efficient. So the technologies are there in the 93% efficiency range, so you lose there another 7%. So coming to the 48 volt architecture, meaning you can increase the efficiency of the DC to DC converter, because here there's no change, right? So you distribute the same power over the AC system, and then you land in your rack. You have the static transfer switch, you have the AC to DC converter, and then you can take the benefit in the DC to DC converter and the distribution, and also in the DC to DC converter on the motherboard. Interesting is, and I will explain later, that the efficiency of these ones can be increased compared to the classical voltage regulator modules by another 3%. So that the total loss reduction by using 48 volt is, according to my calculation, and the numbers may vary a little bit around this, depending on the architecture or depending on the details, 43%, so I said roughly 50%. And key is that you have obviously a lot of reduction of losses in the conduction losses, because you have only 1/4 of the current and then 1/16 of the losses in all the connectors, transferring the same power. So when you look to the motherboard architecture and drilling now into details, then we have here 12 volt motherboard, the classical one, and I depicted here the typical setup. So you go into the motherboard with the 12 volts, and then you distribute it to the to the CPUs and to the memories, and you have here the conversion stage, which is today mostly a multi-phase buck. You can see that on the motherboard either as a built-in component or as a standalone component. And you use for both, so for CPU and memory and other auxiliary devices and memory, the same architecture. So when you look to the DOSA standard 30 amps module, you have a 93% efficiency at 1.5 volt, and this goes even down when you have 1 volt. But it's a very low cost power conversion. You know, you have only semiconductor devices, very high optimized, and when you look to the 48 volt conversion, you have to change on a couple of conversion steps here. From you have the 48 volt boost, and then you have to go directly from 48 volt down to 1 volt, which is kind of a challenge. And therefore, you need to change your DC to DC architecture to a different circuit and topology. And but you stay. There are still some converters which convert from after a conversion from 48 to 12 volts. You still have some 12 volt to 1 volt converters. So, but in the end, keep in mind you have here 97% efficiency and 93 in the 12 volt version. So when you look to the onboard converters, it's very interesting. This is the classical circuit. You may be familiar with this. So this is the synchronous buck. You have the freewheeling transistor and the forward transistor. You have a choke. You have a driving IC. You can buy this from millions of suppliers or TI. This is one from Linear Technology. Key is here, it's non-isolated. It has basically 2 power semiconductors and 1 innocent inductor. So it's just a chip plus a little bit power electronics. When you go to the 48 volt DC to DC, then you see and then you see that you typically use here a 2-stage approach. You have an LLC converter, which is typically a full bridge, converting to the secondary side, and then here, this voltage is a little bit higher than the output voltage here, so 2 volts, 3 volts, something like that. So that the synchronous buck, which is operating, or the secondary side basically, the synchronous rectification, this is a current doubler architecture here, operates very efficient, and that is the key. The reason why this 48 down to 1 volt converters are so efficient is because you have a transformer. The transformers are very high efficient. They transform the voltage down to a very low level, and then you have the rectification here, which operates at very low voltages, contrary to here, because this is also kind of a it's not a rectifier. You can pretty much compare this, but the step down value is here much higher than here, right? So here, but the component count is much higher. You see that it's isolated. This is obviously wrong, copy paste error. Just to check your after lunch performance. So it's an isolated. And we have 6 power semiconductors, when I count correctly, 1, 2, 3, 4, 5, 6. We have 3 inductors, you know, there's this resonant inductor and this filter inductors, and you have 1 nasty transformer together with the control. But on the first glance, you see obviously this is much more component costs, and you get some better performance, so 4% better efficiency, but you have the higher costs. So what does that mean for us here in this open rack family? That means we have for the lower power level, so low means 12.5 kilowatt. These are definitely 12 volt systems, but we also offer for the 33 kilowatt. There's no way to go around the 48 volt. You know, we have the 2 systems which are roughly 30 kilowatt. But the currents which are handled here are really crazy, you know. So we have 250, and so in this case we have 100 amps of blades or clips, power clips inside to transfer the power to the bus bars. And here we have 250 amps. But it's from the technical point, it absolutely makes sense to go for 48 volt to limit the currents flow. You can see that outside here, I don't want to touch ground too much. I put this slide for completeness. Here again, I want to show the V1. We have 100 amps here to handle inside the rack, and for the V2, we have 250 amps. So, like I said, it's instead of 100 amps, instead of 10 watts per 1 milliohm, you have here 62.5 watt for power losses. So in the boost bar clips. So that means, especially design challenge is here the interconnections in the 12-volt system. The reason why I put this up is, and that could probably one question to be answered here in the community. I found the 12-volt clip already been defined, and also from the insulation voltages, it should be also usable for the 48-volt. But the spec in the open compute community is kind of vague on the 48-volt arena. So I think we have some solutions here already, so I should include that probably here as well. So what you see here, this is a typical gear to rack boost bar connector, and the challenge of this blade is of this clip connector is to be below 300 micro ohm, and in order to limit the power losses. And I found here from Method Electronics, or a vendor of these connectors, interesting diagrams of temperature rise versus current, and then here's a voltage drop. You see that we have at 100 amps is this roughly 16 millivolt voltage drop, which corresponds to 3.1 watt per 100 amps, which is an efficiency drop of 0.25 here per 100 amp clamp in the powertrain. So this is kind of a challenging component, yeah. Even though it's simple, it's not just a connector, but you have to make it very low ohmic. And I want to show you here what we have done since the beginning of OCP for Facebook for power supply. So we have done this shelf design. We started with 700 watt, and coming to let's say the efficiencies possible on the AC to DC conversion. So I mentioned the point of load conversion. We are for the 12 volt 93%, for the 48 volt 97%. When we look now to the 12 volt power conversion AC to DC, so 230 volts down to the 12 volt, for a 700 watt power supply, we see today a 94% efficiency peak at 50% load. And for the V2 we have reached the 96% for 3,900 watt. So everybody knows that it's higher, and that it's easier to achieve higher efficiency values for higher power units. So the lower the power gets, the more the losses influence your overall efficiency. But keep in mind, so we have for the 12 volt lower power levels 94% efficiency, and 96% at 50% load for the higher power levels. And when you look to the roll-off curves of the efficiencies, you see that we have here, I took this from a qualification measurement. This was a requirement of the V1, and our unit is obviously higher, otherwise I wouldn't show that. And you see here that we are already peaking here in advantage. So the higher the input voltage, the higher the efficiency. That's clear because we have a lower current standard in the input. And you see at 180 watt AC, we are a little bit above 94% peak. And when you go to 290, then we reach the 95%. So, but this is 12 volt. And when you go to the 98, when you go to the 48 volt power supplies, we also have done a lot of things. And obviously, I show you here our high performance unit. So here we are in the 98% arena now. So keep in mind, 100 is the limit. Okay, so we are not able to do 100% efficient power supplies today. With some tricky things, we may do that in the future. But that's what I wanted to give you as a message. So for the AC to DC conversion, AC to 12 volt, we can reach the 96. So my engineer, advanced tech said, don't present the 96, go to 96.5, you will lead them to the wrong direction. He said, hey, show me the product which has 96.5. And we are on the roadmap we have, but in mass production we have the 96% version for Facebook V2. And for the 48 volts, the 98% is also, you see this is a cat drawing. So this is our next product for a larger search engine provider, and we are now delivering 97 point something. So in the nutshell means between 12 and 48 volt conversion, you have a difference between 1.5 to 2% in the difference. So to summarize my little excursion to 12 volt versus 48 volt comparison, my assumption is due to this, let's say, over the 100 years proven concept to increase the voltage and then increase the voltage and increase efficiency. My assumption is that we will have 48 volt systems much more in the future. And when you look to the roadmaps of the board manufacturers and also on the key OEMs we have, we will go in this direction. The good thing is 48 volt is a safe electrical voltage, so you can live with functional isolation. So I would like to consult you guys on the high voltage version. So because then we have to think about clearance and creepage and also need to have basic or reinforced isolation. But I'm wondering the first day when a board manufacturer comes to us and say, hey, can you consult us and how can we do the integrated power for high voltage? I think that could be a scenario for the future. Here again, the loss comparison, it's evident that you can save here roughly, what is it, 8%, 6% efficiency in that range. And in total we have 43% loss savings with 48 volt. Obviously we have to take into account that on board level, if you do that, you have to spend more money for your DC to DC converters to convert from 48 volt down to the 1 volt. Obviously you have 16 times less losses in the distribution system, and the high power systems are much simpler to design with 48 volts because of the nice feature of the functional isolation. Basically, creepage and clearances keep the same. Board mounted power, like I said, is then more complex. Delta has for all, I have to say that here at the end, okay, for all OCP versions, obviously we have power supplies available, so if you need one, let us know. And again here, the peak efficiency comparison, 98%. For the 48 volt and 12%, and for the 12 volt we have 96% at 50% low. So with these key messages, I want to leave for the discussion, and hopefully I get some good questions from the side. And next time I have the green color, okay? All right, thank you very much for your attention. Yes, okay, perfect.
Thank you very much for a good explanation, much more clear right now after last show when you asked why industry going in that direction. Right now from engineering standpoint, I'm clear why direction going in the 48. And one of the questions, many people investing so much money in 12 volt infrastructure. Did you have a plan to design interceptor or converter device for 48 as well?
No, that's already existing.
Yeah.
So these are standard modules which you can buy also.
No, I mean for OCP
okay.
design, for reuse 12 volt infrastructure in a rack, but using half of the rack for 48.
Okay, so you are talking interesting thought, yes. So for an intermediate solution, you mean you have part of it is 48 volt, part of it is 12 volt?
Yes, something like that. Because, for example, a lot of server can be available on stock or available on current operation. And of course, during migration for the new power voltages, of course, new rack coming to the data center. Yeah, and of course, customer like to use existing server infrastructure.
Do we have that, a mixed voltage rack? But could be a good idea for us, right? Thank you for that nice product development. Okay, so I understand. Yeah, klar, sure.
You showed a 96% efficiency on the old legacy centralized UPS. Now, to me that seems very high. In this room there's people who run colo. In colo, you tend to run a very low utilisation of centralised UPS for quite a considerable amount of time until you start to get customers. Are you achieving an unloading of centralised UPS, not switching to eco mode? You've got everybody switching into eco mode.
This is the eco mode.
Yeah, that's in eco mode because a lot of people don't run eco mode.
Yeah.
So the reality of what you find outside is you don't find 96%. I'd just like to ask people in this room who have run data centres in non-eco mode with low utilisation. What kind of efficiency they are? Anybody? 95? 94?
It's 2% less, okay. Give me that credit, okay. Yeah, I think I know the direction you want to head for. So to give you, I don't want to run into this discussion on UPS versus versus BBU. Okay, so Delta has both solutions. And actually, when I run to customers in Germany, yeah, they need to comply with this EN 560, I think that's the standard. And there are some arguments which we may discuss in a further workshop between central and decentral backup. Yeah? There are some arguments pro the central backup, and people don't want to touch that point because of several risks of fire risk. They don't want to have the batteries in the white space, blah, blah, blah. So, and to be really frank, I mean, a real online UPS with 2 power conversions gives you a seamless, perfect conditioned AC. All the other solutions, also the BBU, when you really think through it, it's a line interactive UPS. It's always line interactive. It waits for the moment when the grid fails, and then it runs into, and you always have some kind of transition. OCP customers can tolerate that. We have a couple of them in doing the BBU solution, but they also understand customers' desire to have here perfect, secured AC grid on their input to the OCP racks. Yeah. So, and the latest UPS developments are showing clearly 96%, 97% sometimes. But also here, I mean, I have only taken, typical values, which you see there. When you go to the roll-off curve and you want to do it precisely, you have to go 20% load, 30% load. So I just wanted to show you the key differences here. Okay, so anything else to the nice world of power? And I'm really happy that you need power, right? So yeah, thank you. Millions of servers, that's good to know. Yes.
Any other questions? Yeah, my question was more about
Yeah.
putting the UPS like as a whole data center or in the rack.
Yeah.
You want to leave the discussion, but
Yeah, no, I mean, we can touch quickly ground on it. Imagine you kick the UPS out and then you have here the battery and you have the battery feeding the output in the moment when the grid fails. You lose, so it's a non-interactive UPS function, like I mentioned before. And when you keep the UPS here in the front and you want to really have online high performance conditioning, no eco mode. Yeah, because with eco mode you also generate a non-interactive UPS. When you really look into it, when you have an eco mode and when the grid fails and then you switch here to this path, it's also non-interactive. So real online UPS, and if customer require, if you want to have that, then you have to eat the frog and spend 4%. Yes.
But if you like put your batteries in the racks,
yes,
and you do not have a central UPS system,
yeah,
that's benefit for the for your power consumption.
Yeah, klar. This is it's comparison to the eco mode. It's the same as the eco mode.
But it doesn't matter then that you use like 12 volt or 48, or those batteries also work on 48 then?
Yeah, we have 48 volt battery backup units and we have 12 volt battery backup units.
So you don't have to convert it back.
No. And it's always the case when you have a 12 volt system, you suffer from when you have a given power, then you suffer from the high current because of your low voltage, right? So it's always good to increase the voltage and down to and up to a limit where it's not a hazardous voltage to you. So that means 48 is perfect. And when you go above 60, you risk that you get a shock. Yeah. Okay.
If you switch to 48 volts, would it be possible to reuse the current racks and reuse the current connectors? From your perspective,
if you keep the current constant, yes.
The current.
Yes. Yeah. So if you keep, so basically that was what I said here.
Yeah, but the current will go down.
Yeah, klar. You can use because the voltage. So basically here I mentioned that for the clips, for instance, so for the connectors, they are rated to 600 volt, 850 volt DC, so you can reuse them.
And yeah.
I'm not 100% sure on the server. That is clear. On the server, it's clear.
The server, you have to
but on the distribution system, you can reuse. Yes.
So you can reuse the rack.
Yes. Yes.
Would that be dangerous? Plug in a 12 volt server and a 48 volt?
No. That's probably that's what you should not do. No?
Yes, I shouldn't, but I will eventually. Stability.
Yeah. So that's the risk if you have a. If you have a 12 volt rack operated at 48 volt, and then you have a 12 volt server, it needs to be coded somehow. Yes.
You can also put diesel in your petrol car.
Yeah.
You can put diesel in your petrol car. Now you can put petrol in your diesel car. Not vice versa.
Yeah, it doesn't.
I'm a little bit picky here. Because of the thinner.
Diesel. You can
put petrol in the, but not vice versa. You can do that.
You can try, but
yeah. Okay.
In practice, it's actually you are thinking to have a power shift of AC to DC, 230 volt to 48 volt, to put in a 19-inch existing rack. That is possible. We could do some retrofit just for the power shift itself. But if you are connecting different voltage in the system, it creates some concerns.
Yeah.
So using existing rack might be a good idea. Using the existing cable trays from medium voltage to the rack distribution, that is also safe. But for the equipment side, we need to discuss.
Yeah. And to take a 12 volt rack and retrofit it completely with 48 volt, I also don't see a concern. But you shouldn't mix.
No, you shouldn't mix, but it makes sense to if you invested a lot of money and time in putting thousands of racks in your.
It's interesting that bit about modification. People don't always realise that you don't really make any changes to the rack in the data centre where it operates in the white space. When you're running OCP, the rack and all its kit comes away as a big lump. It's a rack scale, so you can do all the modifications outside of the space. The way OCP is implemented into data centers, you never bring in boxes of servers and then plug them in.
No.
It's a different approach to, so that modification might not be so difficult when you get back to the factory.
But you don't have to modify anything at all.
Yeah, there is what the comment that was made though, that if you plug, go to 48 volt and you plug a 12 volt in, so it's compatible physically.
No, it's physically not compatible.
Yeah. No, if it was,
I would hope so.
Yeah, they have different connection points. I think it's impossible to plug a 48 volt server into a 12 volt server into a 48 volt. You need to be very strong.
If you're looking for the slide about connectors, it's a 12 volt, it's a vertical.
Yeah, and the orientation is different.
And some cradle, for example, like AFF or Cake, have an interception, like light, not exactly, like interception, horizontal and vertical require different physical power distribution. It's not able to do.
Yeah, but the question was, can I use my 12-volt bus bar configuration and then up it to 48?
Answer no.
Okay.
You need to change your boost bar.
Yeah, the orientation of the boost bus is
Yeah,
different,
you
right?
need
Yeah,
to instruct
okay.
your boost
Yeah, I
bar
forgot that
and
one.
mount in the same fault,
Yeah.
different boost bar and different
Yeah,
power
yeah.
distribution. Of course, it's a cost of money. But you need to looking for your electricity bill and each number available in that presentation, doing something in your body.
So I can do a recommendation, buy a new rack, it's good for us.
Back to the questions, I think regarding the discussion of BBU and UPS, it still depends on how the application is. Is it a colo? Is it a hyperscale data center? We are not Facebook, we are not Google, right? We don't have a redundant network all over the world. If you want to have a BBU, they just want to have a 30 minutes backup, so they could switch to another cluster and just dump this data center. But that's not possible for us, for enterprise to do that. So still, I always put all this presentation into a work considerations. What you should do is that evaluate your application and
use case dependent.
choose a feasible or optimal option for your application. That is what we are going to suggest.
Yeah. Okay.
Can I answer your question?
Sure.
So are there arguments for or against putting the 48-volt power supply central? So where you have background.
48-volt central.
Yeah, that's what we used to do in telco. Telco land.
Yeah, I think that's the old world. Sorry to say that.
So no, it's not a problem. So why?
Yeah, because 48 volt. Yeah, I mean.
What would you lose?
Yeah, you have a lot of power loss. I mean, you have the 48 volt distribution system, and it's better to distribute the higher power at 230 volt or even at high voltage DC. That's what we are also doing for some OEMs from us. We have units which convert three-phase to 400 volt and then 400 volt DC. And then we distribute the 400 volt DC in the system and then convert it down to 48 volt or even 12 volt. But I wouldn't I wouldn't recommend to distribute the 48 volt because of the high losses. You have to spend a lot of copper, but people are still doing that because of the nice batteries. The battery voltage is standardized. Okay.
That bit is an interesting question because often in a telco the busbar infrastructure is in place. You don't have to go and buy.
If you have that.
If it's in place, then I think it's a good thing.
Yeah. If you have already
invested.
invested.
Build it,
Yeah. If you already invested in the 60s, I'm just kidding you. For the 48 volt system, I would reuse it, right? You have to.
You need to keep in mind the energy requirement for the whole telco cycle. It's usually the 5-7 kilowatts for your cell sites required. Only one rack consumes around 30 kilowatts. What kind of corporate like this one you need? It's expensive.
Yeah, it's expensive. But it's interesting to see the different technologies which have been used, and they all had their use case. I wouldn't abandon and say, "Oh, these guys have been stupid." No, I think they had their certain reasons to do that. Okay.
Peter is actually expert for the power electronics side, and he's also designing.
That's my problem.
Some new ideas for data center or hyperscale or maybe high voltage to 750 volt or 800.
We go up to 800 volt.
And then we could have some direct distribution to the rack level. So we are working on this project. We could have some more discussion with Peter on this.
Yes.
We also want to know your concerns and other.
And Menno, as I understand, this is a regular event, no? Once a month, I think. No?
Once a quarter.
No, and then I can update you on our progress. Yeah.
Just one more question.
Yeah, sure.
With such brilliant efficiencies now moving towards the 48 volt distribution in the rack, where is 380 volt DC distribution that you started talking about?
Yeah.
Where is that going to go? Because the gains it gives.
Okay, so we can maybe I should have introduced that in the present.
The future in the
yeah.
48.
So where are you losing your power? I think. Yeah, basically. Yeah. as a model
Yeah.
in the
Think-
I think next time I spend more time on this because we have lots of slides on this. So basically, you change this system here, right? This is the AC distribution system, and you change this distribution system to a DC high voltage distribution system, and then you get these resistors much smaller. Yeah. So the total efficiency gain, I owe you the numbers then for the next time. So, but it's really a trend. We see that customers are coming back to us and say, okay, for this portion we want to go for 400 volt DC or even 800 volt DC. And then having, instead of this UPS, they have a central rectifier, 750 volts rectifier, and then a line interactive battery. So this is, and then they come close to the wind power architectures and the solar architectures. You know, in the total picture, and I will give you next time, everything runs to one technical solution. Yeah, it's really true. It's okay, so the crazy power engineer leaves you along with all the questions.
Thank you, Peter.
All right, thank you.
Behind. So we will take a short break to 2:20, and then please come back here in the meeting room. We have some juice and coffee outside.
I think we should close the other PowerPoints because there's some logic.
on top of the Broadcom SDN, which is more native to what the ASIC can do. Oh, sorry, let's go back. OpenNSL gets you abstractions of create me a trunk on between those ports, assign an IP address to this port, etc. And then there is OpenFlow, which is the standardized abstraction of an ASIC. And on top of OpenFlow, you would have a number of other controllers. You would have Open Daylight. Originally, there was also Floodlight. I think Floodlight is sort of in decline or already declined. There's ONOS now, supported by OnLab. There's BaseBox by us, which I will speak about later. So there's a choice of software. Now, assuming I have bought a switch. What options do we have? Within OCP, there was the Open Network Linux project. So, as a proud OCP member, I go to opennetworklinux.org/ACL, HCL, which is Hardware Compatibility List, and I check. This is a much longer list. It's just a screenshot, which also has one of Agema. And then you see capabilities. So is it ONL certified? What is ONL? ONL is a Debian-based Linux operating system that runs on the embedded system that actually controls the switching ASIC. As such, it is a fully complete Linux. And then we have the question of what of the previous APIs, or what of the previous programming interfaces is supported, and you find no. Sometimes you actually find a yes with those 3 asterisks, which means please contact your vendor because it's not free. So the answer for all of that on OCP's Open Network Linux is no. So you go and you actually cannot get it. You cannot download it from GitHub. You can download some pre-built binaries as part of Kort from OnLab. You get pre-built binaries from some of the vendors. So in principle, you can get it running, but it's not free. There are reasons for it. First of all, Broadcom is sort of picky on the SDK, so you cannot. The SDK itself is not open source, so you can't open source the entire operating system. However, one could actually provide more binaries that would actually make you going on at least OpenFlow. I have no good reason for why this is not the case. I also spoke to some people at ONF that were sort of surprised and said, yeah, we should do that. I think so too. It should be done. If we walk up one level and we ask ourselves now, what controllers can we put on top? Controllers means what is the choice of control plane? There we have, again, 3 choices. We can go with the standard, let's say, non-SDN, which is a distributed IP control plane, routing. There's a ton of BGP extensions recently defined by the ITF. There's quite a number of data center providers that run BGP within the data center. And you don't need any controller for that, and you can run that on a number of Whitebox providers, software Whitebox providers. There's the other option, that is, you use SDN, you use OpenFlow controllers, and that is ONOS that is being used for Kort, central office redesigned as a data center. There you would have a standard OpenFlow controller with an OFDPA 3.0 southbound interface from the OpenFlow controller. And the question is, how does that then integrate into the data center? So ONOS itself has a BGP speaker interface, which has a subset of BGP to then integrate into a legacy control plane. And pretty much the same is true for Open Daylight. I think they are most of the time interchangeable. I think Open Daylight is overall a bit more mature in the code base because they started a bit earlier, and it has a lot more southbound interfaces like netconf, like even SNMP and so on. So Open Daylight is much less open flow driven, although you now also do have netconf interfaces south of ONOS. So OpenFlow is not the only choice for either ONOS or Open Daylight. There's a third option, BaseBox, which is much more lean and purely OpenFlow, and I'm coming to this in a couple of slides now. I think next slide even. There's an intermediate way of controlling networks. That's at least how I see things connected. That is, you either use a path computation element, so that is a centralized box or a centralized function, and that goes together with MPLS or a legacy, any other legacy networking. So you do a centralized steering of the route computation, and then MPLS, and then you use MPLS to signal the path setup in a legacy way. So you do have a range of choices from traditional IP-based networking up to or down to whatever you prefer, pure SDN control. Pure SDN control means the separation of control and data plane, and for most intents and purposes means a centralization of the control plane within a data center. That is something that many people would like to have because they would not want to configure the individual switch or router. So you actually want to have a centralized view of your network, and that's what you get from those controllers, and that's what you also get from a BGP speaker or from a PC. Let me briefly introduce what we did because we thought there might be another way of solving the problem, and that is BaseBox-D. BaseBox-D, you can find it. It's an open source project on GitHub. It's a small open flow to netlink vice versa controller translator. So it embeds. You can put it either directly on the Whitebox switch, or because it is an open flow controller, you can also pull it out into a separate server, and then it speaks OFDPA to the switches. And you can use Linux, standard Linux IP route to configure the box. The box itself looks like a standard Linux box with a number of interfaces. So that means you can send and receive. So basically the first step is the physical switch connects to the controller. The controller creates a number of tap interfaces on the Linux system, and then you see a Linux system with 54 ports. And then you can do whatever you would like to do, like generating, for instance, a VLAN bridge, attaching ports to it, attaching VLAN IDs to it, etc. Why do we do netlink? Well, basically because we can take the entire zoo of Linux tools and put it directly on the box, or put it on the server. So we don't need to write a new BGP speaker. We don't need to write any new adaptation. People who know how to deal with Linux can configure this switch as well. What the switch does is it works on the switch abstract interface. It creates an abstraction. It has a tab manager at the netlink, listener and speaker. We did some extra controller. So BaseBox works either directly on the switch, so you can even also install it on the switch. You can run it separately, or you use what we call core, which is creating a big switch abstraction of a domain of switches such that it collects the number of switches, it creates the inner topology, and it only exposes the outer ports of a switch topology such that it can be configured by the OpenFlow controller. So by that, we are then achieving what the PCE or what the BGP speaker would be achieving as well. The next question is, how can we make the network configuration persistent? Right now, what OpenFlow does is it's configuring table entries in the pipeline of a Broadcom switch for our purpose. When either of those components are being rebooted or are dropping off, these configurations are gone. State is lost. So a hard part of this is, how can we make state persistent? Sorry for this. I think what we are using for this is LCD. LCD is a key value store, which is a distributed database. It's part of where it comes with controller. It comes. Where does it actually come from? It came up with systemd networkd, but then with the.
LCD coming from the CoreOS guys, basically under this Kubernetes scope.
From the Kubernetes, let's say ecosystem or framework. Okay. So this is where it came from. What it does, it's a distributed database. You can store key value pairs. You have at least 3 instances, better 5 or 7, and then it's a rough consensus database. We use that in order to store the configuration of data, and in that it is not much different to what, for instance, ODL or ONOS are doing internally as well. It's just a way of using the means of what Linux has available on board, and we're using systemd networkd to read from the LCD database. So normally what you would do in order to make your network configuration persistent in a Linux, you have the /etc file system where Linux stores whatever configuration data. The outsetting of etcd was, I can actually boot my container with an empty etcd, so with an empty etc file system. So I can boot a virtual machine, or boot a container, and it pulls all the configuration before actually going into operation from an outside database. So this is cloud native design for containers. This is how you can store the entire configuration. We're using that for just the network configuration, but it's how you would do it when you only have Linux available. And well, this is what we have done then. This is as open source as it gets. So basically, you can get BaseBox. You can also get the entire binaries from us because of some limitations of the NDAs with Broadcom. We cannot give you the entire world for free. So that is how we integrate into OpenStack. OpenStack then has Neutron, which is the networking component. We have an ML2 driver, which writes into etcd. We have what we call etcd connector, which reads from etcd, writes into systemd networkd, and off it goes. And then there's some failover. So we have an etcd cluster. So we also have redundant controllers, etc. But that's basically networking done within Linux as far as we could push it. Conclusions. I think I was hopefully pretty fast. Open networking has come a long way. You can get most of what you need from Open Network Linux. Then you have to search around and ask friends if you can also get the final bits and pieces from your vendors, from your whatever partners. Still, there's somehow something sometimes missing. The whole controller northbound interface discussion is still open. There is now a discussion within ONF also about using netconf as north or even right north and southbound. There's the open config, restconf, whatever. We propose to just use Linux. And well, whoever would like to try it, we would be happy to assist. But just go and download and try it out. Okay, questions?
What is your support model on this one? Let's say customer wants to download your controller and they implement it. Are you going to support it, or they're on their own?
We license this one in between here. So this is what we would like to get some money and license contracts. This is intentionally made as an open source project with essentially no support except for a mailing list, but we also get, of course, the regular open source support licenses.
Okay.
Anyone else?
Does it also run some Intel cards? Intel?
On Intel embedded systems or on Intel ASIC? Intel ASICs? No. You mean the Fulcrum ones, the S6000? What we can do is to run. It basically depends on the OpenFlow that the Intel speaks. If this is what you're referring to, the Intel OpenFlow, the open networking thing. There was a switch, I think, 3 years ago by Intel. Is that what you're referring to?
No, not directly, but I was just curious.
So there's if the switch speaks OpenFlow, there's potentially a little adaptation work to be done from OFDPA of Broadcom to whatever other version of OpenFlow. That's possible and should not be too hard. Correct me if I'm wrong, Toby. If you require us to, or if the question is, I only have this switch from vendor XYZ, then it always requires to have the SDK and to fully recreate an OpenFlow agent on it. And that would be, so the question is OpenFlow the right API? Facebook uses a different one. Facebook uses OpenNSL, which is sort of a different abstraction. I think we're having some internal discussions. Is it higher or lower? It is a different abstraction. OpenFlow lets you specify more and in a smaller, in a finer granularity, as opposed to OpenNSL, which is naturally more limited in functionality to pure data center use.
In terms of tunnel encapsulation and decapsulation, A, I'm not sure what is supported by Linux, and B, what is then transported through BaseBox D to OpenFlow?
So I think in Linux you have a lot of support for VXLAN, for GRE, Geneve. None of that is unfortunately at the moment transported through BaseBox D. That's
okay. So we're talking
only
about VLAN.
We're talking about VLAN exclusively at the moment. We're working on layer 3 at the moment, which will be end of Q3. VXLAN is the next on the roadmap for before the end of the year, but we're not yet there.
Any other questions? Thanks, Laban, for the presentation. Okay. Next, we will have Dimitris. Dimitris will introduce the hybrid solution for the NOS. Thanks, Mike.
It's just recording from the speakers, but if you want to,
Okay, so let's continue with IP Infusion nodes for Whitebox, SDN, and NFV solutions. I think we've heard a lot about hardware. Somebody said that software has become, very important for the next generation solutions. Let's see a little bit more about that. So let's take a look first of all at the traditional SDN architecture, NFV and Whitebox, and what are the basic principles that they have introduced into their network. Starting with the SDN architecture, one of the main parts, as we probably all of us know, is to be open, to have open programmable APIs at different layers, whether it is control plane, whether it is management plane. And another important aspect of the SDN was the separation between the control plane and the underlying data plane. So having a simple switch to do forwarding of packets and then offloading the whole intelligence into one single entity, which is the controller, right? We can think of additional, additional principles within the SDN architecture, but I believe these two capture a lot about that. NFV architecture, the software is center stage, and along with virtualization, approaching the networking solutions differently, using servers to do even 1 gig, 10 gig, 40 gig networking functions. And last but not least, Whitebox. Whitebox has evolved into my understanding as a side effect of the SDN architecture. So again, we see the need for open and programmable APIs, and of course, a separation between the hardware and the software. And this kind of separation gives a flexibility to the end customers to select hardware and software from different sources, and so the networking solution becomes more flexible, more independent. Let's see a little bit more about the challenges that those three kind of architectures and approaches have brought along. Starting with the SDN, one of the issues that many people are facing is scalability, whether it comes at the controller side or whether it comes at the data plane side, with flow table size, with the TICA memory, and so on. Interoperability is another issue that we are facing to some extent with SDN solutions. NFV, in some cases performance, and of course when it comes to different types of interfaces, where there's 1 gig, 10 gig, 40 gig, and using the right card brings along some issues. And with Whitebox, this is the area where we see the demand for deploying Whitebox into all kinds of network. But then we realize that, do we have the right full feature set to approach that? Do we have the needed carrier grade performance to be more successful? And of course, at the end, which is very important for data centers, but also telco customers, is the support, the maturity, and the stability of the complete ecosystem that the Whitebox solution brings along. So having all this kind of architectures and challenges in mind, we from IP Infusion, we thought that we are in a position to address these new needs and challenges of the market, because we have all the ingredients in place. We just need to package them correctly and offer that to the end customers and provide something that makes sense in both areas, both Whitebox and NFV. So almost 2 years ago, we introduced OCNOS, Open Compute Networking Operating System, to provide a solution for Whiteboxes which can address the data center, but also the telco and the carrier business, right? And in addition to that, we also have Virnos, which is a pure NFV solution, and can be deployed in different types of applications, whether it is a CPE, a router effector, and we will see more about that. And both solutions offer the management plane that is up to that level with advanced framework, our own solution, including netconf and other features. So that gives you a little bit overview about how we are trying to address these new areas in terms of Whiteboxes and NFV. Now, looking at the benefits is to some extent the answer to the challenges I mentioned before, where somebody who is looking for a Whitebox solution is looking for something that is a solution and not just one or two features, whether it is a VLAN feature or just VXLAN or maybe layer 3. Typically, most of the customers want something that works now, but also gives the flexibility to enhance that if there is a need. So IP Infusion offers a full feature set solution that addresses layer 2, layer 3, and MPLS. And that makes a difference. In addition to that, it is a carrier-grade solution that has been tested over the course of many years in the past, and in different kinds of networks. So we have the scalability and high performance that is required to address these requirements. And of course, which is important for many big customers, whether it is data center or telco, is a seamless integration, which enables them, to lower the risk and lower the effort moving from the traditional networking into this disaggregated. Let's look about OCNOS, how it is built, what are the important components, and why does it really make a difference as opposed to some of our competitors or traditional solutions we find with the usual system vendors. So we have actually architecture that sits on top of traditional switch, whether it is Broadcom or could be also Marvell. In these cases, we're seeing different ODM vendors, one of which is, of course, Agema. And on top of that, we have a complete solution, control plane, management plane, and the integration into the chipset for forwarding. And we bundle that, and we offer that as a, bootable image on different kinds of switches. What is important is, of course, the ingredients that we have within our solution and make a difference for our customers, right? And the ingredients is quite important because enables IP Infusion to compete at different levels with customers, with competitors for our end customers. So looking at the ingredients, we have our ZBOS, which is the heart of the system, which is a control plane. It's a protocol stack that has been sold over 300 customers worldwide for the 15 years, and has been deployed in different kinds of applications, whether it is data center, whether it is telco, whether it is satellite communication. So essentially every device that has a need for a networking feature, ZBOS has been a very reliable solution. And along with that, we have our own management plane, which is used. And very important, the integration onto the silicon. As a matter of fact, this kind of separation between control plane and here data plane was part of our solution since 2000. So again, this is a proof of our SDN approach, if you want, where abstraction between control plane and underlying data plane has been right from the beginning. And that gave the flexibility to many of our customers to deploy ZBOS into their own system solution. An overview about the platforms that we support for different ODMs, and mainly we are focused on Broadcom, but we have discussions with Marvell, we have discussions with Mellanox, and Intel and other chipset providers to have the flexibility to support OCNOS on their hardware platform. Again, solutions, we would like to approach both data center, interconnect, whether it is layer 2 or layer 3, and also service providers. So these are the 3 areas that we focus. We have examples of OCNOS deployment. We have examples of big POCs that we are doing right now. We see a lot of interest. And we believe that all of those 3 can be a very good area where OCNOS can be deployed. As I mentioned before, the core of the heart of the system is our control plane. It's the protocols that have a unique architecture where almost every protocol runs as a separate Linux process. And essentially, many of our competitors are based essentially using the same open source that came from ZBOS and then evolved into Zebra and Quagga. Management plane. This is something that also gives a unique advantage to many of our customers because besides CLI and SNMP, they have a need for transactional-based management and the ability to put on top of our infrastructure different management protocols. So besides CLI and SNMP, we have support for netconf. We see a lot of interest for supporting netconf, and this is something that we will see that will become even stronger in terms of deployment. So another interesting roadmap thing is that we plan to do an integration with the Open Daylight controller. Again, starting with a netconf client that will talk to our switch, and especially for network topology and discovery and pushing the configuration to a network client from the controller. That is one interesting scenario that we plan to introduce in later on this year. With respect to integration on Agema, we have a long list of switches that we support from traditional Broadcom Strata XGS with 10 gig, 40 gig, and 100 gig. This new platform based on the Broadcom Qumran looks to be very interesting for many telco customers. And just want to give you a brief overview about what is currently happening with respect to the feature set. So we plan to have a very interesting release mid of this year, and supporting quality of services, And besides layer 2 and layer 3, also MPLS features, as you see here, layer 2, layer 3 VPNs, MPLS OEM, and also external TCAP memory that enables us to scale above 700,000 routes. That is a quite interesting implementation, and that is something that can be tested from June 15th. Of course, right now we support layer 2 and layer 3, so if there is a need or an interest to test this platform, you can talk to Agema to get the hardware, and from us you can get the software. Let's look at some use cases that, I mean, we can talk about more use cases, but one use case is utilizing layer 3 solution in typical leaf and spiral closed architecture. So we have here core tier 1 routers. We have the spines and here the top of rack switches. And one approach is to use a pure layer 3 design for many reasons. For simplifying the solution, for using a non-blocking infrastructure, and maximizing the performance. In this case, based on our solution, you can use BGP as a layer 3 protocol, and netconf from a management perspective to automate the configuration of the individual devices. So in this case, what the situation would look like is you have autonomous system, same autonomous system for the core routers you have for the spines, the same autonomous system, and then every top of rack switch will have his own autonomous system number. And this is one way to set up the topology. And then use configuration and push that through netconf to each device. So that's something that can work now, and you can test it in your network based on different types of our switches, whether it is 10 gig, 40 gig, or 100 gig. Same with that. Let's look at our NFV solution, which we call Bernos. So here again, we use the same control plane as with Oknos, our own protocols for layer 2, layer 3, and MPLS. We developed our own data plane based on the InterDPDK framework and provide a solution based on WindRiver Linux that comes as a virtual machine and can support 1 gig or 10 gig interfaces at wire speed. So this is a very interesting solution for customers who want to complement their infrastructure with an NFV solution and use the single look and feel for both white boxes and NFV. This is one interesting scenario. Of course, different applications where it can be used as a VCB, can be used as a PE router, or a VPN IPsec. Also in the service provider, like a BGP route reflector, supporting full internet table, can also use as a peering device, and supports open flow and flow-based forwarding as well. In addition to that, we have integration with OpenStack for specific use cases, and also with Ansible. And with that, I would like to thank you. If there are any questions, I'm happy to answer now or maybe afterwards during the networking session.
Any questions? Okay, thank you. So next one, we will have Dhiman to explain to you our own ecosystem and hardware architecture, so that you are able to plan your network in the future.
Thank you.
Well, how are you doing? Good afternoon, everybody. Hope you are still with me.
Yes.
So what I will do right now is, it looks like, it's end of the day. So what I like to do is make it more engaging with you, right? So let me start with a question. If there is a network that you would like to see, what would that abstraction be? What would you like to see in a network that happened? Anybody can give me any attribution? What that network would be? The network of the future. Imagine, take your mind to there. What is future will provide you? Anybody?
That you don't have to configure it, you just plug it together and it works.
Zero touch provisioning already there. Anything more than that?
No wires.
No
wires. It's just me in Amsterdam. Yeah, and some light seems available instead of.
Yeah.
Of course, we can read. Yeah, and self-oriented everything.
Yes. So a future of a network would be self-held, self-configured, something that will able to fix itself. And that abstraction is right there right now. Actually, AI, artificial intelligence, is already being integrated. And I'll give you the brief of what's happening in the network. So today's session is not about talking about Agema. I would like to make it more educational so that I can interact with you, give you the perspective of where network is going and why OCP has, OCP actually given a birth to a fundamental things, and that fundamental thing is open networking. Open networking. Open networking can be taken as the building block of what future has to offer. A lot of people think that SDN has given the birth of open networking. It is not actually. The service providers and in general the industry felt, and I was when I was working for Nortel as an architect, we have contributed to industry with so many different things. Policy enabled networking, and I will go with each of them. ATM has phased out. When you take a technology and you wanted to push it through, you need to look at what it is purpose, what problem it's solving, right? ATM became very complex. SAR technology couldn't take hold in the chipset. It was very difficult to implement. It was expensive. So ATM fall down. Do you think SDN will fall down? No. There is a purpose as to why SDN is coming to exist. And it started from an experiment in Ethane project. And I'll go over it. So what open networking is doing is innately it will reduce CapEx and OpEx of your network through the disaggregation model. And that is important. And OCP has provided a platform for industry to contribute, both in software as well as in hardware. And this is paving the way for everybody to take benefit of this disaggregation model. Rather than being bogged down by a closed system, you are now suddenly open. And with this openness, it is paving the way for programmability to occur, because now software vendor like IP Infusion, they can focus on what they do best. Hardware vendor like us, we could focus on what we do best. And this is called network decomposition. And through this decomposition, each subsystem can able to do what they're supposed to do, and then we can able to easily integrate. And that's why standards are created, APIs are created, protocols are created to bring them together. So SDN and NFV has two different purposes, and I will discuss about it. And what it's doing is that, and service provider leading this market, I talked with a lot of service providers around the world, and service provider say, okay, what I need to do is I need to create a future of a network. I need to create a service, and they call it intent networking. It's coming. And intent networking is the beginning of intelligent networking, which would be self-healed, self-configured, built on artificial intelligence, and it can able to make determination of how the traffic can be moved forward. So intent networking is actually started to happen, although I put it 2020, which it will materialize. Intent network started to happen And I'll talk about a little bit on one of the service provider that implementing it or want to implement it. So I just gave a glimpse about open networking. Open networking is moving away from locked system. Merchant silicon is paving the way for you to now get into a very different kinds of system, the system that opens up. If you will create, so what we have done with this hardware model based on open silicon, the reason I'm talking about open silicon is that there are certain silicons that you could able to actually access them, like OpenNSL. One of my colleagues talked about it. There are other things that is done like SAIs, switch abstraction interface, and so on and so forth. There are harder abstraction layers being created, and industry is contributing through OCP. And OCP is actually contributed through the form of SAI to the industry, so allowing you to map certain tables even to the upper layer. OpenNSL can provide you APIs for upper layer, so does the SAI can provide you APIs for upper layer. So this abstraction is called open networking. Not only open source as a point of view, but the point of view that how far you could do. You know, if you have an imagination, it is possible. Nothing is impossible nowadays. So what we are providing only open network install environment with the dial tools, and the NOS vendors like IP Infusions, they need support. We provide that support to integrate their NOS in our hardware. But beyond that, we are also contributing OFDPA and so on and so forth. So if you have to buy a hardware from us, you can buy a hardware from us or XYZ. You are not bogged down by, okay, I bought a hardware today from Agema, what do? I have IP Infusion software, or I have IPOS software, or someone else's software on this. That what you are getting is a choice. You can take this hardware today, and if you do not like this vendor, you can throw it out, take another hardware. You have the same software you can use. For example, if you have IP Infusion software, you could use. You do not like IP Infusion software, you could put IPOS software or any other vendor for that matter. So the flexibility is enormous in that regards. It's giving you a choice, and that choice is important for service provider as well as for even data center. Although the need of service provider actually differs from that of a data center. So what we are doing, we have different class of product line. We have provided ONI and Dial, and we have two different packages now. One package is ONL based, ONI, Dial, another is Debian based. And we have contributed both of them, specifically ONL based one for Qumran based platform, we have contributed to GitHub. So you could download that, you could do your own experimentation. We are also working on OFDPA based platforms. There are certain constraints with it. For example, OFDPA innately port mapping. So in the front panel of the switches, there are lots of ports. OFDPA cannot identify those ports, so we are trying to see how port mapping can be done. But OFDPA can only see CPU-based port, which is management port. So you could use a controller to program it, but you could not connect your controller to the network port, you have to connect to the management port. That's the only difference. So, stages of SDN and NFV, what's happening? As you see, separation of hardware and software, paving the way for everything to materialize. Decoupled is what we are talking about, open networking. Control separations and programmability is SDN. Cloudification, where you integrate OpenStack and so on and so forth. and decomposition of network, as I talked about. That's where policy-enabled network comes in. I want a service. The intent of my network need to accommodate the service that I do want. So, any question here so far?
Dhiman,
Mm-hmm.
let's assume this is a perfect world and everybody agrees. OCP is going to be the future. What's, in your view, the perfect migration?
In terms of, there are two different kind of world that we can see. One is NOS-based world, another is API-based world. In fact, one of the service provider I talked with, and I've also talked with my colleague Joanne here, there is a different future also coming, where the service provider wants an unified abstraction layer like SAIs, but extending over CPUs, even controlling fans, power supply, all this information through a hardware abstraction layer, and then creating the API for upper layer. So the two different worlds that they do want, one is NOS-based world, another one, what we call metal networking. It is bringing the power of the metal without so many software layers to the cloudification software. So that now you could access without having to have so many sauces there. Think about a burger. You put too many sauces, it's gonna get ugly. But use unique balance of spice and other sauce, it will give you the flavor that you want and the taste that you want. And with the metal networking, this is another thought process coming to the industry, is that can we do like metal cloud? There is a company started called Big Step. They started metal cloud. Can we do something like that in networking? And that thought process is already started. So we are looking at traditional world, actually a mix of traditional and non-traditional world, which is based on hybrid NOS, where you have an open flow agent and you have traditional software, and then you have a purely API-based world. That's going to be something that's coming next. All right. So here is the SDN ecosystem, open networking ecosystem. At the bottom, we have differentiated portfolio of switch. I just put Agema name over here, but it could be anybody's name. On the top, you have hardware abstraction. You see different kinds of hardware abstraction. OpenNSL, SAI. OFDPA is not quite hardware abstraction. There is a bottom of it is in hardware abstraction. Top of it, it has in between certain metadata. And then top of it, it has protocol agent. Indigo being one of them. Now, recently they are using RU agent, RU controller-based solutions for OFDPA. FBOSS is actually contributed by Facebook, and FBOSS uses OpenNSL and SDK mapping. There is a reason they wanted to do this. As I said, getting to the metal. Facebook started it. Not only Facebook, other people are also doing that. FBOSS being one of the, contribution to the industry and a contribution to OCP as well. The next one is Big Switchlight OS is not quite near to FBOSS or OFDPA, but it's their own version of open flow based solutions. But one of the important one, and I talked with one of my colleagues here, is FORCES, forwarding, control, element, separation. That particular one, FORCES, actually is the older one. Before even SDN started, Ethane project started, and Ethane project, the researchers were experimenting how to create elastic routing architecture. If you look at OFDPA model or any other model, you are pushing your thought process, meaning controller's thought process on the switch. Switch has no way of communicating back what it can able to support, what capability it has. Forces provides the way for switches and the controller to exchange their viewpoint. Yes, I do support this. I can able to take the command line that you are going to push me to do. So forces has two parts to it. One is for switch forwarding plane, another is for controller, and I put it up there. So the next level is the choice of NOS. There are open source NOS and there are vendor specific NOS. For example, PIK8, Cumulus, IP Infusion, Broadcom ICOS, SnapRoute, these are vendor providing those NOS. SnapRoute, of course, has some open source element to it. So the IP Infusion contributed to the industry, both Quagga and Zebra OS. Am I correct, Dimitris? So they have done significant contribution to the industry. Open switch, we are trying to see what we could do to support open switch, as well as Microsoft Sonic. Microsoft contributed to the industry with their own operating system. So the next level up, this is called network hypervisor. Why it's called network hypervisor? Because imagine a network that you do have, and so many different routers in between. If you have to look at from the top, it would be so ugly. This part, that part, that part, this part. How about there is a controller that sits in between, and you can just drag and drop a line from one point to end point, and that gives you the visibility. Open Bartex has been contributed by ON Lab to the industry to provide you that kinds of visibilities and overlay. That's why it's called network hypervisor. And FlowVisor, actually, Stanford experimented with FlowVisor. It was actually the early network abstraction level controller, but it couldn't do what OpenVRTX is doing today. So that's why a lot of people do not know about FlowVisor. Next level up, OpenDaylight, Root Controller, ONOS, and Forces, and a lot of third-party software. Any question? I'm going to give you a pause here. There are a lot of questions you can ask. Yes, please.
I mean, look, you talk about an ecosystem here, and it looks like there are far too many options.
Yes.
Why is that?
Far too many options.
Your view.
Industry is still pondering over what is the best way moving forward. So many contributions happening from the industry itself. So many people are working on it. For example, OpenDaylight, take for example OpenDaylight. OpenDaylight and OpenStack overlaps in the neutron level. So and industry now thinking, should we give up the neutrons L3 forwarding mechanisms? And depends on OpenDaylight because both of them overlapping. So there is a collective thought process coming along on that. So as we move along, we will see only few will survive, few controller will survive. Why I am emphasizing on OpenDaylight? Because there is a behind the scenes so many things happening. AT&T recently contributed OpenDaylight's integration to ONAP, Open Network Automation Platform. It is developed based on AT&T's contribution of eComp. Why I know all the inside? Because AT&T recently announced partnership with Agema Systems. I didn't want to disclose this, but it is already there in a press release. They're choosing one of our platform, and it's not like I know it; it's everybody knows it. Probably John knows it, right? So, it's OpenDaylight has a lot of flexibilities, but is that something that you could depend on innately right now? Probably not. It has a long way to go for reliability. But Beryllium's and Baron's, the recent releases, are much better than Helium and other releases. So if you ask me which one between ONOS and OpenDaylight, in fact, ON Lab I had that question. If AT&T is taking Open Delight and contributing to the industry through ONAP, then what happened to honors? Right? And I asked that question to one of the colleagues there at one lab. Their answer was not quite specific. Right? They said, well, it is for industry to make the choice, right? Which one to get. So to answer your question, yes, as we get experience on this, we'll decide which one we'll take. Whether people are going to follow AT&T, I mean service providers, and then enterprise and data center will follow through it, that remains to see.
Let me try to pose the question differently.
Okay, go ahead.
It's sort of a similar question, but it's, I mean, if you look in the list, you have on the bottom layers, you have even more choices than at the
Up layer, yes.
I would have expected it's the other way around. I mean, if you go from sort of from a certain degree on, it's only one system, two systems which sort of survive. Looking at the operating system level for IT, sort of their bets are made, the thing is gone, right? Then if it comes to application, you have a lot of choices. I would have expected to higher up in the stack, the more choices you have. It looks like the opposite.
Yeah, well,
why is that?
Why is that? Because we love traditional world, right? We wanted to do the open networking, but at the same time, majority of the deployment is on the traditional world. We need NOS. You see the number of NOS being contributed, and number of companies is starting the NOS to contribute to the marketplace as well. I mean, IP Infusion was there since 1992. I have been using in 1999. So I have been using in Nortel. I mean, their OCNOS version is recent, but they were in the OEM marketplace for a long time. So why they decided to come and just contribute to the marketplace at the same time, bring this newer version? Because open networking is paving for them. This disaggregation model is helping those companies to bring in their NOS and compete with. Now you suddenly have a choice. Of course, you cannot apple to apple compare with Cisco's iOS or Junos, but Dimitris will tell that their softwares can be able to compete. So there are a lot of companies talking like that with their own NOS, that yes, now you have a choice. Will you go with Cisco or go with us, right? But you have a choice on software, choice on hardware. And when choice comes in, when more vendors compete, what happens? Price goes down, giving service provider the leeway, right?
Yeah, but we still need to make decisions here. So it looks for me, it's not the market is not ready to make that decision at the moment.
There are certain yes.
One question about technology standpoint. Why you position an open contrail between two different very important pieces of the cake? Yeah?
Yes, very interesting. It has capabilities to do what OpenVRTX does, right? Which giving you the hypervisor capabilities of network. At the same time, it's a full-blown controller. It competes with Open Delight.
But not the same feature set as Open Delight has.
Yeah, Open Delight has lots of southbound APIs. Open Contrail only have 2, 3, and I have it.
1.5.
1.5. You can see that. Well, XMPP is there, NetConf is there, and BGP is there, so you can make some choices there. Right. So that's the reason it has 2 portions. One of the reason I put it in hypervisor, you'll see Open Contrail can provide you the capabilities to do provisioning of VXLAN tunneling. And Open Contrail actually, of course, you can buy it from Juniper for the full-blown with support of VXLAN provisioning. But Open Contrail, as it stands today, is a force to reckon with, actually. We cannot ignore that, both sides. Although not at the Open Delight level, but it is something, yes.
Yeah, I think maybe a nice thing to mention is that we could, for example, give out IP Infusion's 60 days, what is it, trial at the moment?
It depends. It starts from 30 days or 60 days, but typically, if the customer is focused, we can give 60 days plus.
Yeah, and then we could do the same with like SnapRoute. You can trial it, and ICOS on the same Agema switch. So if you're not satisfied with the CLI or the API of one OS, you can easily switch even without buying. You can test it and see if you're satisfied. And there's a lot of choices, yeah, but you can also filter and then try a few of those.
Yeah. So certain choices, of course, although I put it in a layered description, let me see. So for example, Axos. Axos have connectivity to OpenStack, but it better goes with ONOS. Axos, ONOS, OpenVertex, they are actually from same ON Lab. ON Lab contributed 3 of them together. But if you look at in the industry right now, OpenStack leading the way, right? Other ones are not picking up. So as I said, sooner or later, people are going to make their determination which one to move forward. In the cloudification level, Eucalyptus, actually Amazon took it and made their AWS. But OpenStack is also a force to reckon with right now, right? I mean, industry has accepted OpenStack. And it is being, a lot of line codes are being added and it's being very stable. The current Metacard release is pretty stable. I experimented myself and I can tell you that is very stable. And I had difficult times with everything else and provisioning, but Metacard release of OpenStack is good. So this is service extraction and service chaining is something has not been done yet. It is something the service provider wants, and it is something that I talked about that innately connects with intent networking. And this is where more and more you will see new startup coming in, new services being developed, and service chains are being created. But there are other ways to create service chains. I'll give you an example. Any question? No? So far. Okay. So I can go deep or I can just be on the surface. Ask me question, then I can go deep down or surface. So this is an example what I wanted to do. And the reason I'm giving you that, because one of the customer I wanted to do this. Imagine, and I just said that take your mind and imagine, and this is not an imagination, that is a reality that I wanted to do, and it is possible. Imagine that you go to OpenStack Horizon dashboard. In Horizon dashboard, if you have created a network, it's very simple. Once you create the network, you'll see the network icon in there. Anybody familiar with OpenStack? Yeah, you have seen in Horizon dashboard how the icon that is being put. So imagine instead of seeing that icon, you see your entire topology right there, entire topology in the Horizon dashboard. Now what you do is you click on one of the switch and you see poof, something opens up, and that would be your netconf form. Now, Dimitris gave you a heads up on something about how their company is working with OpenDaylight. Guess what? We are connected, right? So what can happen in here, and I'll go into technical details on this. So you can click on this and let's say a BGP form will appear and you can configure the BGP. So how it's going to be, it's going to be pushed through Neutron's plugin. We are going to create a small plugin, and through that plugin you could push it down and then you could use netconf to configure the box, right? And so one thing within OpenDaylight, you need to imagine OpenDaylight has a northbound interface and then southbound interface, and not all so if you imagine it is a square box, so northbound API to connect to southbound API is not that straightforward. Some of them connect, others not. So what you could do is you could create an RPC call to connect the southbound API to the northbound API. So and possibilities is there. I experimented with that as well. So now the future of seeing the world topology is possible. How it's possible? There are two ways you could do it. You could pass the LLDP packet to the Open Daylight, or you could use OpenFlow DP Discovery Protocol, OFDP, and pass the topology to Open Daylight. Through this, you pass through the plugin to the Horizon dashboard, and now you have topology. So you just imagine, you click, you could bring up the CLI, or you could bring up a form and configure it. So the future that we are talking about is not far. Actually, it is much more near. And the way industry is moving, this is, I mean, could be possible by next year. Right? Any question here? So you have now two choices. You could do the same using OpenContrail, right? Or you could do it with Open Daylight.
What do you think strategically? Because you are speaking as visionary, yeah? What do you think? Because some of the guys are dreaming to have open vSpeech running on top of bare metal.
So,
what do you think about that ideas and that approach?
So I will tell you something about, and there is an article I wrote about OpenFlow, right? So OVS need OpenFlow. Anything with OpenFlow innately requires a lot of TCAM space. And TCAM is very expensive. And a product like Tomahawk level products, right? Unless you wanted to go upper class product like Qumran-based Jericho Blaze product, and that has external TCAMs. But internal TCAMs, if you are using TTTP of the OpenFlow, you will innately take away lots of tables. And the mapping of the table is not that straightforward either. So I see that industry is pondering whether OpenFlow is the best way or other APIs is the best way. And second part is what industry is trying to pick up. Right, that's what I see. And I'll give you an example as well. Any question here so far? Yes.
How does networking continue into the server? I mean, so far there is the bottleneck.
Networking continues in the server. I see, so one of the company I worked with, that is C-Plane Networks. And C-Plane was giving me that vision that we actually, Agema is partner of C-Plane. I find the companies and I try to be partner with. And so we went into several service providers together. And the imagination was that a lot of functions would be done on the servers, networking including, right? But we find out that more and more service providers wanted to offload things from the servers. And I do not know the reason. Everybody has their own vision and version of it. But more functions that they would like to do in there on the NFV side or VNF side of the world is something different. Like for example, BBU functions. They want to put it in a server, right? VBBU. VOLT functions. They want to put it on the server, but not the regular network elements, right? VCPE, for example, all the service provider wants, but they want it a different way. They want to provision an application right onto the switch, not on the server. That's how I see that from the customer feedback standpoint. So here is an example how you could use netconf to provision VXLAN tunnel on your servers. Or you could actually do, there are several ways to do this. The BTAPs, if you're familiar with VXLAN, there are 3 ways VXLAN will work. Static VXLAN, where you know the IP address of the other end, well, non-UDP port, or the multicast, you depends on the PIM, or MPBGP, EVPN kind of scenarios, which IP Infusion support. But if BTAP is on the switch and you want to provision
all the switches, the best way to do that, you cannot go to each CLIs and do this unless you use MPBGP, VPN. Even if you use MPBGP, you have to still configure VXLAN information on the switch. So the better way to do it using either Open Contrail would be the best way to do that, using NetConf. So Open Daylight, why cannot do it? Because Open Daylight internally there is a complex behavior, might not be suitable in this scenario. But you could write certain RPC call or plugins to help you on that. Any question here? No?
So essentially, the switch needs to have a NetConf interface.
Yes, and your software already have. There are RESTful APIs you can also use, but NetConf is better way because see, NetConf uses modeling capabilities from Young model, and so it is something that is constantly being used, and I am seeing everywhere else that it is being used.
And it is secure as opposed to REST API.
Yeah.
That is a very important.
Yeah, that is another aspect of it. But more REST is not depending on Young model, but NetConf is, and the more reason is modeling is very important in service provider network as well as security. Here is an example based on what I know a service provider is doing. And what they wanted to do, as you see, they are implementing on the edge level. They're starting with edge and using this open networking platform. It gives innately them the capability, CapEx and OpEx is down, flexibility, what they would like to do. So what they're doing is that, so imagine this is not even 3G, this is even 4G, right? 3G would be 100. I was talking with the service provider and they say, oh, I need a 100 meg switch. It's 100 meg in 100 base T internet. What are you gonna do? I want to connect with VPU that's providing me 100 meg, and that is serving 3G services. And I was like, is it? So, as you see, service provider has not upgraded their network. They have not coped up with the technologies that currently available. Now, it's a lot of investment for service provider, but open networking with open platforms, if they can, and they're already trying to do, accommodate this and trying to take it. Once they take it, they will drastically, their CapEx and OpEx will go down, their revenue will come up because it's innately providing much more service capability than they can currently able to provide through their network. So this particular switch, you could imagine that what the service provider need is certain telemetry features. And there is a project sprung up called OpenConfig. And OpenConfig is a streaming model based on Young model, and actually it is derived from Kafka type of architecture. Kafka, if you know, from Apache. Apache is a open source, I would say, right? So in Kafka, there is a subscriber and publisher model. Publisher goes and provides that information to the subscriber, and so on and so forth. This is the same model with OpenConfig. So the switch, when it supports OpenConfig, service provider can able to create a model. They can see the entire model of the network, and not only the model of topology. Topology has not been created, but what the device support. And they can push that information, collect that information accordingly. And this is a deployment happening. I have not shown you the other side, but this is on the mobile side of the network, how they are deploying. Any question?
So, let me ask on the OCP, the sort of interface cards you plug into the switch. Are there versions for long distance?
You are talking about optical side?
Any.
So only constraint that I do see, the higher the speed you go, for example, if you want 100 gig, 80 kilometer, there is none. You need to use transponder. So you can use a transponder, and then you could use a mask, right? And then, if it is DWDM, you could use transponder and mask, and then you could take over the lambda, right, on the other end. But if it is 10 gig, 80 kilometer is already solved, right? Right? It's a Z version. Yeah. But 100 gig, 25 gig, that solutions is not there. You need transponder. But specifically 100 gig, I already seen the request. And for that, you need a transponder. And the irony is that a box could be, let's say, $10,000, 100 gig switches, 32 port. But optics is also not expensive. But guess what? Transponder would be $13,000. And that's where drawbacks comes in. Industry is still trying to do this. And I know there are several projects Facebook is working on, as well as it's on the OCP as well. Is there a committee being created, John, in terms of optics?
There is, and there's been work done on optics, but on engineering the pluggable optics down to, they've taken the 10 kilometer 100 gig optic that normally runs on a duplex single mode, and they've re-engineered it down, and there's a new OCP optic that only goes 500 meters, and it's an absolute fraction of the price, and that's causing a total transformation in the data center space. But to get involved with long distance transmission, that's where it's going to go out to the telco boys in the other organisations. We see we're stretching ourselves too far to get into those like 80 kilometre. A data centre really has got no need for anything longer than 500 metres, even in the biggest hyperscale. So it's kind of outside of our territory. I don't see us bringing that.
Maximum maybe 1 mile. 1 mile maybe.
No, 500. Even the biggest ones I know is 300 metres long.
Depends if you have people.
I'll show you. Even if you take the hyperscale data centres, they're normally 300 metres long. You put the central concentration in the middle. So if you plan it wrong, then 500 metres is not enough. But if you plan it right and optimise the position with the configuration of the hardware, then you never exceed 500.
Yeah. So as you see on the previous slide, I gave you a hint about intent networking, right? Right over here, you see the intent-based configuration flows, how it's being created. You could get the details if you go to openconfig.net, you'll get the details about how OpenConfig works, what is the architecture model, and how it could be supported. So here, what I have given you a perspective. As you know, central office reimagined as data center, a lot of people have talked about it. These are the 3 areas the changes are happening. If you look at this RODOM things, there is an open forum being created for RODOM. It's for add and drop multiplexer. It's a reprogrammable one that you could do for lambdas. And there are a lot of details about it is available, but for enterprise card, this is how it is implemented. And for residential card, how it's implemented. And I gave you an example on mobile card, how it's gonna happen. And of course, you see the centralized DPC functions already started to occur. Virtual BBU functions are already people are trying to move it to the server. eNode B functions, similar, it's moving to the server. So either way you look at data center or the card, we have the portfolio of switch that fits in all. As long as you adhere to the class architecture, you could do. But we also have a 1 gig platform, PoE platform, and so on and so forth that can be used in scenarios, as you deem fit. So
can I just take you back on that last slide?
Okay.
Just quickly. There's lots of questions that keep coming to me from this morning, and it's about what are the impacts. How do I transform my enterprise data center to an OCP data center? It impacts lots of subsystems, and one of the subsystems that people are not aware of is the way you have to create this fiber non-blocking cross network. And people are forgetting about that, and it has an enormous impact.
Definitely.
That often questions afterwards. You have to consider all of your subsystems when you do the transformation.
Yeah. So in the class architecture, there is 3 tiers of spine leaf architecture being created. Facebook recently introduced a thing called super spine on top of the standard spine. So through the super spine, if you have a network with super spine, you draw in the pods, it's not going to impact the super spine. You could literally confine your configuration changes within the pod areas. So there is a network configuration on clause, and there are articles written about it. If you search on FAT tree architecture, 5-tier FAT tree architecture, and so on and so forth, you will see a lot of clause architecture being discussed there. What is the drawback on each of them, and how do you define a clause architecture, right? Yeah.
When you mentioned the word pod, there's a rack configuration in OCP configuration where you're forced to put cabinets in certain grouping structures, and that has another impact on the physical implementation. Now, again, it's short today, but perhaps we'll cover it in questions afterwards. But the implementation of this fiber network actually tells you how you have to put the racks in the white space.
Okay. So I'll briefly go over what happened in our 100 gig portfolio right there. So we have, so I'm just going over our portfolio product quickly. And you can ask me a question on each of these chipset if you would like to, or we could have, I can provide you details on that later. So we have a Tomahawk platform, which is currently available, is a 9032 Tomahawk based platform, is a 32-port Tomahawk, which is 3.2 terabits backplane. We are coming with this 20-port Jericho Plus. 20-port is a unique configuration, so definitely it's a service provider, right? So it's a service provider wants that particular product, and you guess who? You'll know that. And that one also has a Broadwell CPU on it, so giving you the flexibility to do a lot of programming capabilities, right? A lot of things you could do. And Jericho Plus innately provides you traffic engineering capability. Both Jericho Plus and Qumran, you could do traffic engineering. You could literally get into their APIs if you know SDK very well, you could be able to do that. Apart from what NOS vendor will provide you. So the Tomahawk platform, Tomahawk 2 is a 64-port 100 gig switch. Guess what? 100 gig is not end here. There is a 400 gig coming. 32-port 400 gig chips, ASIC is already available. People are working on it. So 32-port multiplied by 400 gig. Look at the terabit backplane, 12.9 terabit backplane, and then 1 RU pizza box. And I talked with the customer and I asked them what you were going to do. They said, I'm going to create a super spine, 400 gig super spine based on that particular switch. So apart from that, we have a 25 gig portfolio of product line. AG5648 is a Tomahawk based platform, 25 gig. We have a Jericho Plus platform on 25 gig. But when you see Jericho Plus platform and here, and of course, we talked about Qumran as well, innately you know that there are a lot of capabilities on it. External TCAMs comes with it. We'll talk about that. And as well as it has traffic engineering capabilities. It is in 2 versions. It's available, Sync E and non-Sync E. Sync E also comes with 1588. So if you are using somewhere you need clocking mechanism, you could use those products there. 8032 is a 40 gig switch. I currently see 10, 100 or 25, 100. I see less of 40 gig. The reason is that 100 gig is a 429 gig channels. Counting the loss, you can come to 25 gig, but it's actually 28.9 per channel. So if you are using 25 gig, 425 makes 100 gig, right? You use 10 multiplied by 10, it gives you the 100 gig. But if you are using 40 gig, you can, I need to break it down to 10 gig. Otherwise you lose it. All right. 7648 is a Trident 2 based platform. All those platforms supporting this one, Tomahawk, everybody do support MPLS, VXLAN, and so on and so forth. All the traditional features and bells and whistles that you want is supported. Anything below Trident you go, it will not support it. So we talked about Qumran a lot. Qumran is like a hot cake. Everybody wants Qumran, right? We have two versions. One is SyncE and non-SyncE, and I can give you details example if you want to. So these are Helix 4 is a single chips. It has Mac and the CPU ARM9 processor building. So these will not support MPLS and features like that, but they're pretty good at for the front end. If you're using for mobile towers and so on and so forth, you could use them pretty well. And here is an example of how the switch has been designed, specifically Qumran level switch. As you see, there is a SyncE interface built into the Qumran, giving you innately capabilities of adding the fan-out buffers and other stuff, but the processing is offloaded to IDT. But the built-in interface is there from the Qumran for SyncE. Two external TCAM will give you the capability up to 1.5 million routes IPv4. As you see, with 1.5 million route, you could literally create this as a core router, depending upon the scenario that you would like to do. So for the price point of a core router versus a price point of an open networking platform, you innately see how much you can save. It also have 4 GB of GDDR5 based packet buffer. And the packet buffer is what happens is that it's dynamically allocated to the port, giving it capabilities of lossless Ethernet, right? Packet buffers, when you oversubscribe, you need the packet buffer, right? In a microburst scenario in a data center, you want to hold the packet so that the packet doesn't get lost. Like Hadoop scenarios and so on and so forth. You could use those packet buffer would be automatically allocated here. But as you see, Qumran platforms does not have a bigger backplane. This is just a suggested 640, 100 gig. You need to calculate into the account that Qumran is not in 1 terabit switch. It is a 790. So you use those ports accordingly, right? Any question there in terms of its design? And as you see here, 32 gig of SSD drive and 4 gig of DDR3, meaning most of our boxes has Linux on it, right? IP Infusion uses CentOS, ICOS uses Debian OS like Ubuntu, and so I can give you an example, and Dimitri, you can correct me if I am wrong. Given the space over here, customer can able to put their own Linux tools, right?
Actually, we're using Debian Linux.
Yeah, Debian Linux, yes. So in ICOS, when it boots up, it goes into full-blown Linux. You could put Wireshark or certain other tools in there. So you could use TCP dump to get information and so on and so forth. So it allows you, it gives you a lot of flexibilities in terms of what you could do with an open networking box. Any question? Not so far? I think I am done. Thank you. Now I'll give it back to Milo if there is no other question. No question.
Thank you, Dhiman. Okay, I would like to thank you for your patience and participation today. This actually brings us to the end of today's event. For this kind of event, we are trying to coordinate with our partner to conduct it maybe once a quarter so that we could learn some new information, technology trend, and some of the cases we implement in the field. I hope that we will see you again next time. The next one should be in August, and maybe we will have another session in November. We will send out the invitation to you as well. Okay. So two more things I need to have your feedback. The first thing is that we prepare one one sheet in your bag. It's just to collect some information for us to improve the organization of the event. So if you have any comments, just let us know. It's in your bag, so if you don't have, we could provide this to you. When you finish this, just put at on the chair or put at the desk at the end. Okay. And we also reserve some time for networking and some discussion. Prepare some soft drink outside so you can enjoy that and have some more discussion with the team. Okay. So I would like to thank you very much for today's participation. Thank you all.
See you next time.